Hi there, this is Intro to Python Development. I'm Christopher.
And I'm Susan.
And what we're going to do is take a look at some introductions and talk about you and talk about the course itself. So who are you again?
My name is Susan Ibach, and I do business development for AI gaming. We help companies help other people discover their code by designing things into really cool games. It's a fun way of learning. I also like to geek out on data and coding, and I also train for marathons, listening to a lot of metal music lately for some reason. I'm metal training. Maybe that's because I'm a spouse and mother of two, and all my boys in the family do geek out on the metal with me, but not so much on the running.
And I'm Christopher Harrison. I'm a product manager and side of Cloud and AI academic ecosystems here at Microsoft. I'm a web developer at heart. It's how I came up. I'm a marathoner, a yogi. I'm a husband, father of one four-legged child. And then you'll also notice, and you saw this on Susan's slide as well, down at the very bottom, our respective social media. So if you want to get in touch with us, that's how you can find us. So let's talk a little bit about you to start to set expectations for the course itself. So the expectation that we have for you as the viewer is that you have a little bit of programming knowledge, that maybe you've played around with MakeCode, maybe you've taken a basic JavaScript course, and now you're just trying to see what Python is all about and how you can start doing development in Python.
Yeah, and you can take that Python skill, this foundation you'll get here, and take that into the world of things like machine learning, web development, or automation and scripting. Those are all the types of paths you can follow once you've got that basic foundation of Python. So we're going to try and give you a bit of a foundation to help you go down that path.
Exactly. And that sort of works perfectly into what we are going to talk about is the Python constructs. So we're not necessarily going to get a lot into the basic concepts of programming itself, but how to do a lot of that inside of Python. It's worth mentioning real quick that we are going to be doing Python version 3, more on versions later, but everything that we'll be doing, with really one or two exceptions, would actually work with Python 2 as well.
Yeah, our real goal here when we put together this course was to be able to, a lot of times when you're trying to learn something, you go find an online tutorial and you think you understand something, and then you get halfway through the tutorial and go, I have no idea what this code is doing. So as a goal here, we're hoping that when you're finished this course, you can go to an online tutorial and be able to follow it. Yeah, there might be some new things to learn in that tutorial. That's why you're doing a tutorial. But hopefully we'll give you enough knowledge to be able to work your way through tutorials to do more self-paced learning.
Exactly. And speaking of self-paced learning, you've given like perfect segues here. I appreciate that. Two real quick resources that are worth calling out. The first is the aka.ms link to the GitHub repository. On there, you're going to find a whole set of resources, the slides, the code samples, etc., that you can use to continue to grow your skills inside of Python. And it's also worth highlighting the Intro to Python course that's on Microsoft Learn as well. So that way, if maybe you don't feel like listening to us talk, but instead prefer to go through text-based modules, you can do that as well. Neither one of us will be offended.
Not at all. Though we have done our best in this particular series to try and make each sort of module very standalone, very simple. So if there's a few things you already know, you can go ahead and skip ahead to the next module. So if it's designed to be such that you can watch just the code demo for one, watch the theory on another. So we've tried to break it up into nice little bite-sized chunks for you.
Exactly. So if you get sick and tired of our jokes, you're not obligated to watch from start to finish. You can dive right to the spots that you want. And speaking of diving right to the spots that we want, why don't we go ahead, wrap this little video up, and then get into getting started, where we'll take a look at doing the installation and what you're going to need to start writing some Python code.
See you soon.
Okay, let's start digging into Python here. Now, before we go anywhere, we probably should answer one question, which is, what is Python? And if we're going to ask this question, we should, of course, answer it with a quote from Wikipedia. So Python is an interpreted high-level general-purpose programming language created by Guido and first released in 1991. Python's, and well, you can read the rest to yourself from there. And let's try and translate that into a bit of English here and what we can actually do with Python. So what is Python? Well, as it turns out, Python is an extremely flexible programming language, that you can really do any type of development that you might want, be it functional, procedural, or object-oriented, and create really any type of application that you might want, including things like web development, machine learning, etc. Python is also designed to be human readable. So that way, if you're not real in tune with a lot of different like C++ syntax and things like pointers and so forth, fortunately you don't have to worry about that when it comes to Python. It's designed to be, well, at least quasi-close to English. Now, why use it? Well, it's a great starter language. Now, what's nice about Python is there isn't necessarily a lot of huge syntax to learn, that you are going to notice, again, there aren't a whole lot of funky little characters and things like that. And it's also going to help teach you some really good best practices that you'll want to use with any programming language that you might be programming with. But it's also a great advanced programming language as well, that again, Python is flexible, so that Python can grow with you. So as you grow in your career, as you start digging deeper into, say, machine learning, Python can come along with you for the ride. You don't necessarily need to go out and learn another language. Finally, Python has a fantastic community that if you're thinking, hey, I want to do fill in the blank, chances are somebody has been nice enough to create a package that you could go ahead and use to perform said task. So the last question then is, what can I build with Python? And the answer is pretty much anything. So you could do machine learning models, you could do AI projects, web applications, which is personally what I find myself using Python most frequently for, automation utilities, and really pretty much anything at all. And again, that's the great power of Python, its flexibility and its ability to grow with you. So now that you know a little bit about Python, we'll close off here, and then in the next video, we'll talk a bit about what you're going to need to start writing your Python code. Now that we know about Python, the next question is, how do we get started? Well, the first thing that we're going to need is somewhere for Python to run. Python is an interpreted language, so you will need a runtime in which Python can execute. And fortunately, all that you need to do is head on over to python.org/downloads, and you can go ahead and grab it from there. And if I bring up that little site, you'll notice there is python.org, and I've got downloads right here, and I could click on downloads, and then I can go ahead and install Python right from there. Now, I'm not going to walk through how to do the installation. I'm assuming that you know how to install something onto your particular operating system of choice. But what I do want to highlight here is you may notice as you're poking around inside of this site that it references Python's version 3 point, in my case 7, or Python 2 point something. And you might be wondering, well, which version should I use? And the answer really is Python 3. Python 2 is there for legacy support. Now, you will notice some applications still require Python 2, and that's fine, and that will come up from time to time. But for the applications that you're going to be creating, you really do want to be using Python version 3. The next thing that we'll need is something in which to write Python. And in our case, we're going to be utilizing Visual Studio Code. Now, if you want, you could go ahead and use Notepad or Emacs or, fill in the blank from here. But VS Code is going to give you a lot of fantastic support for getting in and writing your Python. Now, in order to install VS Code, you can just head on over to code.visualstudio.com and again, walk through the installation for your particular operating system. The last thing that we're going to need is a little plugin for Visual Studio, and I already have that up on my browser here. And that is going to help enable some additional functionality for Python inside of VS Code and help give you a better experience when you get in and start writing your code. you'll notice that when Susan and I get in and we start writing our Python and VS Code says, hey, did you want to use this? Hey, did you want to use this? All of that is there because of that Python extension. Again, all of the URLs that you're going to need are listed right there. I'm going to go ahead and break this video, and then we'll come back and do a real quick demo on how to install the extension inside of VS Code. So previously, we took a look at the 3 things that we're going to need to actually start doing our Python code. We'll need somewhere for our Python code to run. We'll need something to edit it with, VS Code in our case. And then we'll need an extension for VS Code. Now those first 2, Python and VS Code itself, you'll install the same way that you would install anything else onto your operating system. So I'm not going to walk through those, but I am going to walk through how to install an extension, since that will be particular to VS Code. Now, right now I've got VS Code up and running right here, and over on the right-hand side, you'll notice that there's a little icon right there, and that's my extensions. And I can actually just click right here and look through all of my extensions. And so it will show me all the ones that I have enabled. It will show me all the ones that are recommended. And I can actually just do a real quick search right here for, in my case, Python. And so it gives me Python right up at the very top, and I can actually just click install. Now, if you happen to have followed the link from the slide deck, it's really the exact same thing. It's just going to be a slightly different method. That instead of using that little spot over on the right side with VS Code, I'll just simply click install here. It will then say, hey, would you like to open this up inside of Visual Studio Code? And I'll say, as a matter of fact, yes, I would. And I click on Open Visual Studio Code, and now it brings up that exact same screen that we had before, asks me would I like to install it. Well, yes, I would. I click Install, and then just give it a couple of moments here to download, do the installation, and then you'll typically need to close out Visual Studio Code and reopen it in order to activate it. So I'm just going to hit Close, VS Code to open it back up. Oops. And just like that, I'm ready to start writing my Python. Now, if you want to go ahead and add in a file, and we're actually going to see this in the next module, so I'm not going to steal Susan's thunder here, but you'll notice right there is the little plus file. I can click on that, and that will allow me to add in a brand new file. We'll give it a .py extension, and then start adding in our code. But again, I'm going to let Susan show that to you. What we've covered is how you can get the extension into VS Code, so that way we can actually start creating our Python code.
Okay, let's get into some coding. We're going to start off with the print statement, which is typically where we start with most programming languages. When you want to print output to the console to display a message either to a user or to yourself, maybe because you're debugging your code, we use the print statement in Python. It's simply the command print, then in parentheses, the string or the message that you want to display. You can contain it in single quotes, or it will also work inside double quotes. It's one of the unusual things about Python is you can choose either single quotes or double quotes to enclose your strings. Now, just because you can use either one doesn't mean you should go back and forth. Pick one and stick to it. Throughout this course, we're actually always going to use single quotes to enclose our strings. That's a conscious choice we have made. So we're consistent and it doesn't confuse people that half the demos are with one, half with the other. You can choose what you want, but please stay consistent. Always use double quotes or always use single quotes. But it's nice to know you can use either because you might find examples online that switch back and forth or use one you're not familiar with. Another thing you might need to do from time to time is actually ask for information from the user when you're running a program. We do that by using the input function. So with the input function, we pass in a message that we would display like, hey, please enter your name. And whatever value is passed back by the user, whatever they type into the screen, will then be put into that name variable. So it'll be stored in the variable name. And later on, we can then print that name out on the screen or use it in our code as we need to. When you're displaying output on the screen, it can very quickly become quite cluttered, so it's useful to insert blank lines in the output to make it a little more readable. There's a couple of ways we can display blank lines. One, we can just say print and provide open and close parentheses with nothing inside. That will print a blank line. Also, each print statement does put a blank line afterwards. So if you have a print hello and then you say print world, that would actually put a blank line between hello and world. Also, you can put a /n. That's actually a special character that means insert a new line here. And what that will do is that will allow you to put a blank line right in the middle of the string if you need it. One of the reasons print statements are really useful to coding is because we can use them for debugging. Sometimes when we're writing code, an error message pops up or the code's just not doing what we think it should do. So sometimes we'll add print statements, not because they actually make the code work, but we write print statements so that when we're running the code and we're trying to figure out where it's blowing up, to see which lines of code are executing successfully and where it's failing. So in this case, you can see that I saw the message adding number displayed, then hopefully it did the addition. Then I see the message I'm performing the division, and then hopefully it does division, and then I see this error message spewing all over the screen. That can help me figure out where my code blew up. So now I have a sense, since I never saw the message math complete, I know where to go look in my code for the problem. So it's a useful tool when debugging code to add and remove print statements just so you can figure out what's going on. All right, now let's go take a look at this inside Visual Studio Code. Okay, so Christopher's shown you how to get Visual Studio Code working with the Python extension. Now let's go into Visual Studio Code and actually start trying out some of our code. Now, when you work inside Visual Studio Code, you're going to need to create a folder on your file system first. And that's a place where you can keep all your files together that you're working on. So I've already gone ahead and I've created a folder. So as soon as I open up Visual Studio Code, I'm going to want to go to File, Open Folder, and open up that folder that I've pre-created. So I've already created a folder called Intro to Python Development. I'm going to open that folder now, and now that gives me a place to store all the files I'm going to be working on. Once I've got that folder open and I can see the folder name listed over here on the left, then I can say File, New File to create a new Python file inside that folder. So now I can try out that print statement. So we say print hello world. Now, initially, there's no way that Visual Studio Code can tell that what I've written is a Python module. So it's when I save the file that I tell Visual Studio it's Python. So I'm going to save it by going File, Save, or Control S if you like keyboard shortcuts. And once it's saved, I'm going to make sure I call it hello world.py. And that py extension is a cue to Visual Studio Code that I've just created a Python script. And you'll see right away some colors appearing. That's a good sign because it's actually using code highlighting to indicate that the hello world is a string by showing up in red and so on. So I can tell now that Visual Studio Code recognizes this as a Python script. And then I want to run that. So to run that code, and this will be your ultimate test of whether you got all your Python installed correctly, you just type Python and then the name of your script, and I called mine hello world.py. If you forget your file name, don't worry, it's at the top of the tab. And then you hit return, and sure enough, there's hello world displayed on the screen. Okay, so I've successfully run my first script in Python. As I mentioned, you can put single quotes or double quotes around your string. I'm just going to use Control S to save that file again. Go back to command line. I'm going to use the up arrow, which allows me to go to the previously run command and rerun my script, but this time with double quotes around the string. And sure enough, still displays hello world. So as I mentioned, single quotes, double quotes, either one will work just fine. Now what if I want someone to input a value? Well, I could create a variable called name and say input, what is your name? And then I can say hello. And then maybe after I say hello, I say let's print the name on the screen. So let's say hello to the person who's typed in their name. So now save that. Go to my code, rerun that, and it says, what is my name? My name is Susan. And now I see hello Susan appearing in the output. So the input command, said, is a way for me to ask for input from a user, and then I can take that input and store it back inside a variable. Once you start having multiple lines of output displaying on the screen, you may want those blank lines. So at any time, you can do something like print hello, and then I can just say print world, and you will notice those appear on different lines. So you can see hello world appear on different lines. I'm going to show you another useful little command in Visual Studio Code here. We're starting to get to the bottom of the command line output. So just typing the word CLS will clear the screen and take us back to the top of this output here. Useful little thing when you've got a lot of outputs displaying on the screen. Another way of putting output over multiple lines is you can use that /n. /n is an escape character that means please insert a new line. So that will also display a line of code over 2 lines of output. So /n is a way of saying new line right inside a string. This is said really handy when you just want to display output to a user in a console application. But as I mentioned, print is also very popular for coders trying to debug their code. So if I was writing some code that was doing some math, x equals 532 plus 12, and then I say y equals x divided by 0. Now I know that dividing by 0 is going to cause an error, and then I say print, yay, I did math. So I write a very simple little program here, and I save it, and I go down and I run that program, and it blows up. Now, I'm using a very simplified example. You can probably look at my code and guess which line of code blowed up. It's the divide by 0. But what if this was inside a 500, 600 line program with multiple modules and functions? Sometimes it can be tough to track down where that line is blowing up, even though in the error message it does give you a line number, which gives you a hint. So sometimes when I'm trying to debug my code, I will literally write things like saying adding numbers. Promised I would use single quotes here. Adding numbers, and then I add my numbers. And then I'll say print dividing numbers. And then I will divide the numbers. And then I have my print statement saying, yay, I did math. And that way, when I go and I run my code, you can see that the adding numbers message appeared, the dividing numbers message appeared, and then I got an error message. So it can sort of help me flow back through my code to figure out what code executed successfully, and whichever print statement I didn't see is probably the one right after the line that failed. So don't be afraid to use print statements as a debugging tool as you're learning to code. Now, before you get too far into coding with your code, it's useful to get in the habit right away of using comments. Comments are a way of documenting your code. By adding a hashtag or a pound symbol at the beginning of a line of code, that turns your line into a comment, which means when the code runs, it does absolutely nothing. It's there for you as a programmer to remember what your code does, or for someone else reading your code to understand what your code does. So when you run the code, you aren't going to see any output in this case. In fact, you can put comments in front of code that you're experimenting with. Maybe you try a line of code and it isn't working, or it is working, you want to try changing something. Rather than deleting the line of code, sometimes I'll comment out that line of code and then try it again with the difference. So that way I don't lose the old code, I just comment it out in case I need it back. So very useful. So any line of code that has that pound or hashtag symbol in front of it is not going to execute. A really good habit to get into is if you're calling a function or a method, and we're going to cover functions and methods later on in the course. But if you're calling one, add a comment before you call it to remind yourself, what does this function do? Why am I calling it here? Again, it might be really obvious to you when you're writing the code initially, but when you come back to that code in 6 months or a year or 2 years to fix a bug or to make a change, chances are you're going to forget a lot of the code you did. So you'll really appreciate the time you spent commenting when you did the initial work on it, when everything was fresh in your mind. Sometimes you'll have to do some sort of quirky things to make things work. Maybe you're always using single quotes around all your strings, and then suddenly you have one print statement with double quotes. Why did you do that? Well, maybe I should add a little note. If you're printing a string like, it's a small world after all, there's a single quote inside that string. So I would have to use double quotes to enclose the string. So what I've done is I've added a comment here so anybody else who is reading my code would understand why is it I use single quotes for all my strings except this one line. So those are the sorts of things when you do something out of the ordinary or make a function call, add comments so others can understand your code. It's also really useful when you are debugging your code as well. If you've got a long program and something's blowing up, but you can't figure out which line of code isn't working, there have absolutely been times where what I did was I basically commented out, so turned a whole bunch of lines of code into comments, and then sort of would see if the first 5 lines of code in my program worked. The first 5 lines worked, okay, let's uncomment the next 5 lines. Did that work? Okay, still no error message. Uncomment the next 5 lines, and so on until I see the error message. And that can help me narrow down where in the code my error is coming from. So get in the habit right away of using comments in your code, both for documenting what you've done and for debugging. Okay, now let's take a look at how to use comments inside our code. So a comment is any line of code which starts with that hashtag or pound symbol. So if I save this program here, comments.py, and then I run it, python comments.py, to execute that line of code, there's no output. Not because it's not a valid program. I can add a print statement here. Save that, run the program, and you will see the print statement does appear. So it is recognizing this is a Python file. It is running my code. It's just comments don't do anything. That's the point of them. We use them to document our code, and sometimes when we have something like an error, so in this case, hello, it's a small world, if I save and run this code, it's going to blow up. It's blowing up because it's contained inside single quotes, and the string itself has a single quote in it. So if this was inside a larger program, I might find myself trying to figure out, wow, which line of code is blowing up? So I might use that technique of commenting out lines of code to help me find the bug. And so by simply putting a pound symbol here, or maybe I say, maybe I take a different version of this line of code. And I say, well, maybe if I did it with double quotes, it would work. So I have a version with double quotes and a version with single quotes. And when I use the version with the double quotes and I run my code, hey, it works. And I go, huh. So is it really just for double quotes and single quotes is a problem? So I can go here and I can play around. Maybe I'll comment out that line and uncomment this line and test that again and see if indeed, yes, look at that. It's the print statement with the single quotes causing the error. So this is one of the ways I use commenting and uncommenting inside my debugging itself. By the way, handy keyboard shortcut, because I do this a lot. If you have the cursor on a line of code and you go Control-K-C, Control-K comment, that will take the line of code the cursor is on and turn it into a comment. Control-K-U, U for uncomment, will uncomment a line of code that's currently set as a comment. So get in the habit of using comments in your code, both for debugging and for documenting.
Let's get in and take a look at probably one of the most common things that you'll be doing in programming, and that is working with strings. Now, when it comes to strings and actually just variables in Python, it's relatively straightforward to take a string and store it inside of a variable. Now, as a real quick aside, if you're not already familiar with variables, variables wind up acting as placeholders inside of your code for some value. So in my case, first name is going to wind up being Christopher. Now, one of the things that will make Python unique is the fact that you don't have to use any form of a keyword or otherwise to declare a variable. You just simply give it a name, set it to some value, voila, you've created a variable. That's all there is to it. You'll also notice my string literal over here on the right-hand side, and you'll notice that I'm using single quotes here. Again, you can use single quotes or double quotes, doesn't matter which, but you want to be consistent. For me personally, I really like using single quotes. I just think it reads a little bit better than having double quotes. Maybe, you know what, I don't even have a good reason as to why. I just think it looks better with single quotes rather than double quotes. If you want to use double quotes, you're not going to hurt my feelings at all. It's your code. Just simply, again, be consistent. Now, if you want to take two strings and combine them together, you can do that by just using the plus operator. So you'll notice in my code that I've got my first name and my last name. And then you'll notice that I'm going ahead and I'm calling print. And I'm combining that first name and that last name together just by using that little plus sign that you see right there. Let me just grab my pen again so that way I can circle it. That little plus sign will bring that together. Now that works with both variables as well as with string literals. So if I want to bring together a string literal of hello and a couple of spaces along with my strings, then I can also do that just by using that exact same plus operator. One last little side note on our variables. You'll notice that we're using a word, an underscore, and then a word. When you're creating variable names, you want to make sure that they're nice and clear. And if they are going to need multiple words to make it clear, convention in Python is always lowercase and with that underscore that you see there. Now, if you want to modify a string, maybe convert everything into uppercase letters, lowercase letters, capitalize just the first word, or potentially count all of the instances of a particular string, in this case the letter A, you can do that by using upper, lower, capitalize, and count respectively. And down below, you'll see the results of doing each one of those. And then finally, if you want to bring all of that together, you can still do that string concatenation just the way that we've seen previously, and even bring in values from the outside world. So in this little code example here, what you're going to notice is we're going to read in the first name from the input window. So whatever it is that the user types in, we'll bring that in. We'll do the exact same thing with the last name and print that out. And then you'll notice that we can properly capitalize everything by utilizing that capitalized function that you see there. And you'll notice the results. That if I type in Christopher in all uppercase, Harrison in all uppercase, and then I wind up calling capitalize, it will just capitalize that first letter. And so that's how you can get in and start working with some neat little strings inside of Python. Now what I want to do is go off, do a little bit of a demo, and then we'll actually come back and take a look at one last advanced configuration that you can do with strings. So let's take a look at some of those neat little string functions that we saw previously. So I'm going to start off by just simply typing in first name equals Christopher. We'll just get that stored. And then last name equals Harrison. Perfect. Now, like we've already seen, we can concatenate things together by using that plus sign. So if I say print and I say first name, and by the way, a little IntelliSense bit of functionality for you. If you see the word that you want already highlighted, all that you need to do is hit Tab, and that will complete it out for you. It'll save you a little bit of typing. So if I say first name plus last name, save this, and then I go ahead and run this, oops, there we go. Make sure I'm in the right spot. You'll notice that it prints out Christopher Harrison. Now if I update this, let's go ahead and put in our print, and then we'll say hello, first name, a space, and then our last name. And again, I'm using that tab to help me out with the autocomplete. Now what you're going to notice is that it gives us that hello Christopher Harrison with the spaces inside of there. Now if instead of printing it out like that, maybe I wanted to go ahead and bring that in from the user, and let me just comment out the code so that way it will still be in existence there. I could go ahead and say first name equals input And we'll say, please enter your first name. And then, and actually, before I do this, I want you to notice right here, that little last name and those little green squigglies, yes, that is the technical term, underneath there, that's Visual Studio Code letting you know, hey, there's something that's not quite right here. If you ever see that, you want to pause, take a look at your code, and see if there's potentially a mistake. In my case, the mistake is that I haven't declared last name yet. Remember, we had it up here, but we've commented it. And remember what Susan taught us earlier, that when you comment out a line of code, that's now not going to run any longer. So let me go ahead and enter in our last name here. And we'll say, please enter your last name. And now, let's go ahead and run this, and we'll see what happens. So it asks me, please enter my first name, Christopher. Please enter my last name, Harrison. Hit enter, and now it tells me, hello, Christopher Harrison. And if we want to go ahead and capitalize everything, we can go ahead and say capitalize and capitalize. Again, we'll save that. And now let's come back and rerun our code. What's my first name? And I'm going to shout it, Christopher. What's my last name? Harrison. And you'll notice the results here that we wind up getting that Christopher Harrison with just the capital C and the capital H, because once again, we've used that capitalize from before. Now, if we want to do things like lower and upper and so forth, all of those are available to us inside of Python. Now, if you want to get in and see some of the other things that you could potentially do with strings, you can take a look at the docs inside of Python. Those are some of the more common ones that you'll find yourself reaching for when you get in and start working with strings inside of Python. So previously, we saw how we could take a couple of strings and combine them together by using that little plus operator. Now, we've already seen this slide, and if you take a look at the code, in particular that fourth line, what you're going to notice there is there's a lot going on. That I've got that little plus right there in the middle with my string literal, and then I've got another plus here, and another string literal, and another plus here, and another string literal. And this can get unwieldy pretty quickly. This is not even taking into account that we might want to be calling capitalize or upper or lower or some of those other helper functions that we might have. And our code's just going to keep getting longer and longer and longer. So let's try and simplify this a little bit. And this is where our format strings come into play. That what we can do is that little output that we see up at the top, where again we're calling that plus sign that we've already seen, or we can streamline this by using placeholders. Now, each one of these outputs that you see up here on the slide is going to give us the exact same string. We're just going to do it slightly differently. So the first one, what we're doing here is we're going in and we're putting in placeholders with those curly braces. Now the way that this works is it's going to be based on the order in which we specify the parameters. So that first one there, that's going to be first name in my case. And that second one, that is going to be last name. Now, if we wanted to specify it, what we can do instead is we can use the 0 and the 1, which then allows us to specify the first and the second, respectively. Remember that counting will start with 0. So that 0 is going to be the first item, and the 1 is going to be the second item. Now, in my example up here, it's not going to make a difference that both of them are the exact same. But if I need to potentially reuse the exact same string somewhere else, or maybe I just want to document it, show, hey, this is going to be the first, this is going to be for the second, this is going to be for the third, then I could go ahead and put in that 0, the 1, and then maybe a 2 later on as well. Now the last example that I want to highlight here, and I want to make sure that I point out the fact, whoops, that was not what I wanted that, there we go. I want to make sure that I point out the fact that this is only available in Python 3. So if you're doing anything that needs to run in Python 2, this last example is not going to work, but it will work in Python 3. And that is where I put in F right at the very beginning, F being for format. And now what I'm able to do, and I love this functionality, is I'm able to now just use my variable names right in line with everything else. This is my preferred method whenever I'm doing string concatenation because it's nice, it's clear, it's self-documenting. You always want your code to be self-documenting. And when somebody comes back, assuming that they understand the little F at the beginning, it's very easy for them to go, oh, that's going to be my first name and that is going to be my last name. Let's see how all of this works inside of code in our next little video. Let's see how we can do that string format. So I'm going to start off by doing first name equals Christopher and last name equals Harrison, just like before. And again, what we could do is we could just simply output equals our hello and our little plus and our first name, our little plus, a space, and then hello and whoops, and then our last name at the end there. There we go. And then I say print and our output, and that will of course give us our, if I run this correctly, there we go. That'll give us our little hello Christopher. Now I'm going to do the exact same thing multiple times and we should just get the exact same output. My goal here is really just to show the different ways that we can do this. So let me comment that out, and now let's do this again by using the little placeholders. So we'll go ahead and say hello, and then we'll just do 2 curlies, and then 2 curlies, and now I'll say format, again using tab to give me that completion there, and we'll say first name and last name. There we go, and let's go ahead and save that, rerun it. Once again, the exact same output. Hello, Christopher Harrison. If I want to maybe be specific about it, so let's go in and say 1 and 0 and go ahead and run it. Now you're going to notice we'll get the exact same output, but maybe if I wanted to reverse that last name and first name, maybe I want to put a comma between them. So I go in and I do 1 and then 0, put a comma in the middle. Now what you're going to notice when I run this is that it went ahead and gave me hello, Harrison, comma, Christopher, without me having to change the order of the parameters, which is another advantage to going in and specifying the numbers. Now, again, my preferred mechanism is just to use that cool little format string. So I'm going to say output equals, and then we'll go F, and now I'll say hello, comma, curly, and then we'll say first name, space, curly, last name, and you'll notice the IntelliSense actually comes right along for the ride there, suggesting first name and last name for me. And now I go ahead and hit save, and I rerun that, and now we're back to that hello, Christopher Harrison. So the big takeaway that I want you to get out of all of those examples is that there are multiple ways that you can do the exact same types of string concatenation. It's really up to you to decide which way it is that you prefer. For me, like I said previously, I really like that last string format with the little F at the very beginning there. That to me reads the best, And you'll also notice that there's a lot of other programming languages that have a very similar construct, such as in, say, JavaScript or in C#, for example. I also really like the fact that it's self-documenting because I can very clearly see, that's where first name is going to be, and that's where last name is going to be. And that's how we can work with strings inside of Python.
Okay, so now you've learned how to work with strings. Let's take a look at how we work with numbers inside our Python code as well. Just like strings, numbers can be stored inside variables. We always want to give those variables nice, meaningful names, get in the habit of that right away. And we can pass those variables into functions like the print statement. So the print statement can take a variable that contains a string, a variable that contains a number. It really doesn't matter either way. It'll just print what it's received up onto the screen. Of course, when you're working with numbers in your code, at some point you're probably going to have to do math. Calculations to figure out people's salaries or taxes and things are pretty common inside our code. So we can do math with the numbers, and the good news is it's going to look a lot like it did when you were in school. You've got the plus sign for addition, the negative sign for subtraction, you've got the slash for division, and then the only thing that's a little bit different is it's an asterisk symbol for multiplication, and an exponent, or to the power of, is a double asterisk. So if I have two numbers here, 6 and 2, 6 plus 2 prints out an 8, 6 to the power of 2, 6 squared, will give me back 36. So we can do lots of different math operations inside once we start playing with numbers. One thing you will run into very quickly once you start working with numbers is that when you start combining different data types, so a string data type and a number data type, Python will get confused. So in this case, I have, hey, how many days in February? 28. And then I just say, hey, print statement. Let's display on the screen 28 days in February. And we've already printed numbers. We've already printed strings, yet when we run this code, it blows up. But why? Well, if you actually look at the error message, it'll give you a hint. Unsupported operand type 4 plus int n string. What it's telling you is it's actually the plus symbol that's confused. 5 plus 6, it knows a number plus a number, I should be doing addition. Susan plus IBAC, two strings, it knows to concatenate the strings together. But when you give me one number, one string, am I supposed to add them together like numbers? Or am I supposed to concatenate them like strings? I'm confused. So when you're working with Python, sometimes you have to tell it, hey, I know that the days in February 28, in this case, is a number, but I want you to treat it like a string here. I want you to concatenate that number to the phrase days in February, so I see 28 days in February on the screen. So we have to do what's called type conversion. Get used to this. You're going to see it a lot in your code. It's going to come up all over the place. So all we have to do for Python is to convert any data type to a string. You just call the string function. So we call the str function. We pass it days in February, which is currently a number. And now it's going to treat that as a string. And now we say, oh, you want to concatenate string plus another string? I know what to do. Put those together and displays our message on the screen correctly. So string function is going to save you a lot when you start working with numbers and strings, mixing the two up. Now, when I do this, I'm actually storing a number as a string. And as soon as you store a number as a string, that also creates some interesting effects. So if I take a first number and I store the number 5 in it, if I put quotes around that number 5, it now treats it as a string that contains the number 5. And the second number is equal to 6, a string that contains the number 6. Well, what happens when you concatenate two strings together with a plus sign? It puts the two strings together, so I get 56. Well, here you can kind of see what's going on, but sometimes this is happening back behind the scenes and it'll catch you. Let's say you're using that clever input function to ask a user to enter a value. Turns out the input function will always return a string. So if you ask a user to enter a number and they enter 5, and then you enter a second number and they enter 6, and then you say, let's print out the result of first number plus second number, it's going to print out 56. So just like earlier, I needed a way of saying, hey, I know you think it's a number, but I want you to treat it like a string. Sometimes you have a number stored in a string, and you need to treat it like it's a number. I want to do math with it. So there's a different data type conversion. Data type conversion, changing from one data type to another. So last time I was using string to convert from number to string. Now I need to use something to convert from string to number. And I have two choices of functions to work with here. The int function will convert it into an integer, a whole number, 1, 2, 3, 4. Float will convert it into a number, a floating number, or something that might have decimal places. 1.0, 1.5, 2.6, anything like that would be a float. So by using the int function, if I say print integer version of first number plus integer version of second number, or float plus float, you can see it actually does the math correctly and adds 5 plus 6 together and gives me 11. So be very careful when you're working with numbers to make sure it's using it as the correct data type at the right time. And if you're wondering what other situations you might be using numbers in, well, there's basically two situations. One, you're doing math operations to calculate salaries, calculate tax, and so on. And the other place you're going to run into numbers is when we start getting into things like arrays and lists, and you might need to point to an index value. Say, start at this position, go to this position, or go to this row here. You'll find numbers useful for that as well. So let's step back from this and go take a look at numbers in code. So I've got Visual Studio open. Let's go and take a look at some code. So I'm going to create my variable pi. 14159. I know there's more digits than that, but I've got to stop somewhere. And I'm storing that value in a variable, and then I can just print that value up on the screen using Control S to save here. I love using keyboard shortcuts. And why? Just trying to get that message to go away. There we go. And now that I'm here, run my code, and you will see that it displays, there's my number, 3.14159 on the screen. So again, just showing, yes, of course, I can store numbers and variables as well. And of course, once I'm storing numbers and variables, let me just comment out this code. Control-K-C, by the way, the keyboard shortcut for commenting out code. And now I can store a couple of numbers. First number equals 5. Second number equals 6. And then I can add those numbers together. So I can do a print statement of first number plus second number. Because of course, the main reason we want to store numbers is because we're going to need to do math with them. So now I go ahead and I run this code using the up arrow to recall my last command. And it comes back and returns 11. You can change that to a multiply. And then you see 30. I can change that to a double exponent, which means to the power of. Save that code, rerun. And apparently, 5 to the power of 6 is 15,625. I admit that's beyond the capabilities of what I can do in my head. But that's why I like computers. They'll figure that stuff out for me. Computers are good at math. So this is a fairly common situation. But as I mentioned, one of the problems you will run into is, let's say I start asking the user to enter the values for the first and second number. So I say, hey, do an input statement and ask the user, please enter a number. And I'm going to take the number they enter and store it in that variable first num. And then I say, please enter another number. And I decide to store that in the variable second num. So all I've done is taken the value for first number, second number, and taken it from the input statement. The rest of my code is the same. And yet, now when I run, I'm going to change this to a, actually this should probably give me an error. We'll try this. And it goes enter number, I enter 5, and I enter number 6. And it goes, unsupported operand type for the asterisk or the power command. It's like, it's got a string and a string. Well, what's Susan to the power of IBAC? So the problem is it has two strings. I can demonstrate this by changing the to the power of symbol to a plus sign, because now you'll see the two strings concatenated together. So now if I run, and I'll just move this to the top of the screen so you can see it better, and I enter number 5 and the number 6, and you see it come back with 56. So this is the problem I was talking about, where the numbers are being treated as strings, because the input function always returns a string, even if that string contains a number. A little confusing, I know. So let's go in and fix that. So all we have to do is we have to go in here and say treat this number as an integer. And treat this number as an integer. or take this variable and convert it to an integer. And now, when we enter 5 and 6, you can see it actually correctly does the math and returns 11. If you, and we change that to a float rather than an integer, the only difference is an integer is for whole numbers, a float can contain decimal numbers, so the only difference is going to be that when I enter the numbers, it shows 11.0, just a way of me recognizing it's a number that can contain decimals, a floating point number. So here I've used data type conversion to take a number that was stored in a string to treat it as a number. But there was one other scenario where we had to do data type conversion as well. So let's take a look at that one. So I'm going to comment out this code, Control K-C, to do that. And what I'm going to do is I'm going to say days in February. Help if I could type. February, if I could spell February as well, apparently, equals 28. And then I say print days in February, there we go, plus, and I want to concatenate that, total days in February. So sometimes we want to display a number inside a string, on the screen. So now when I go and I run this, go down here, just clear the screen again with the CLS. And we see it again, it blows up. Take a look at that error message, it says unsupported operand type. You have a plus sign is the operand, and you're trying to give it an integer and a string. So it's confused. Python doesn't know, is this two numbers I should add up with math, or two strings I should concatenate together? Because it has one number and one string. So we have to use the string function to convert days in February into a string data type. So now, when I go and run it, it comes back perfectly happily and comes back and says 28 total days in February. So now you have the ability to use numbers in your code, but do be prepared to start doing battle with some data type conversions. String, int, and float could become your new best friends. So we worked with strings, we worked with numbers. I think we're ready for dates. I say that with a heavy sigh because dates come with some extra complications. They're one of the more difficult data types to work with in any programming language. The most common thing we need when working with dates is simply, I need the current date and time. We use this a lot when we're logging errors or saving records in databases. We want to know when it was saved or when that record was written or when something happened. So the way to get the current date and time is by using the datetime library. Now, we haven't covered libraries yet. Trust me on this one, we're going to get there. So for now, don't panic. Just know that I'm using a function that is in a library. This is a very Python type thing to do. There's a lot of libraries that do cool stuff that save us a lot of time. They are your friends. So I'm going to use the datetime library, and in particular the datetime function in the datetime library to ask for current date and time. So we'll just take a look at that and see how it shows in code. So the line there, from datetime import datetime, that's basically saying, get me the datetime function from the datetime library. More on that later in the libraries module. And then I can call datetime now, and that will return the current date and time. And notice, hey, I'm trying to be good with comments here. I'm adding comments to my code so I can remember all of this. So the now function returns a datetime object. So I can say today is, we were learning about data type conversions. If I just pass it current date, it'll go, what? One's a string, one's a date, I'm confused. That's okay. You can just convert your date into a string, just like we could convert numbers into a string, so we can print the output out on the screen. So I now have a way of getting the current date using datetime now, and if I can convert date to a string data type, I can even combine it and display it on outputs. There's a whole bunch of functions you can use once you start playing with date times. That's why they're so wonderful to work with. So again, I go ask for date time now, so I'm storing that in a variable called today, and then I can display today's date. So that's the same code I had before. But you'll actually notice on the top, I've added another function I want to use. It's called time delta. It's in the same library. It's in that datetime library, but it's kind of cool because it allows me to say how many days from today or how many weeks from today something is. So I can define a time period of 1 day, and it's a time delta of days equals 1. If I wanted days equals 3, it would be 3 days. If I wanted to measure a week ago, I could say weeks equals 1. And I simply say, so yesterday equals today minus 1 day. Now, think about how complicated that really is, because if today is the 1st of March, today minus 1 day, well, that's 28th of February. But wait, was it a leap year? If so, then it's the 29th of February. I don't want to have to write programming logic that figures all that out. So it's much easier for me to use this time delta function and let the date magic of Python work and say, just what was the day 1 day ago? And then I can just print that out on the screen. So today was, when I printed the slide, it was the 6th of June, and then yesterday was the 5th of June. So time delta and these features really make dates worthwhile and save you a lot of time coding. What it comes down to is when you're working with dates, if there's something you want to do, there's probably a function in DateTime or another library that'll do it for you. If you find yourself trying to count how many days in a week or months in a year or anything like that, chances are there's a function that'll do it for you. Save yourself some time. Now, what if I'm printing a date on the screen? By default, it was displaying a very long date there. It was date, time, hour, minutes, seconds, milliseconds. If you want to format it differently, you can absolutely just request parts of it. So I can ask for current date.day. So current, I've taken date time now, the current date and time, stored it in a variable called current date, and then I can say, just give me the day portion, just give me the month portion, just give me the year portion. There's also one for hours, minutes, and seconds. And that way, I can decide what part of a date is important to me when I'm either saving that data or using that data or displaying that value. Now, sometimes somebody will give you a date, and then you need to store it as a date. Okay, maybe that doesn't make a lot of sense, but think back to what I was saying in the numbers module when I was talking about when you use the input function and you ask for a value, it always gets stored as a string. So I say, hey, when's your birthday? And it says, I say, my birthday is on the 5th of June, 1999. Yeah, we'll go with that. And then you want to store that value, because right now it's a string, you want to store it as a date. One of the things that's more complicated is when you take a string and you say store it as a date, you have to know, was a date given to you in day, month, year, or as month, day, year? Were you passed in a 2-digit year or a 4-digit year? Did they separate the day and month with slashes or dashes or just spaces? Whew, this is one of the reasons dates are so much fun to work with or so challenging to work with. So if I run this code here, you'll see I've used the function strp time. So this will basically allows me to say, here's the format I will be receiving. So I am expecting a date format, which is day, then month, then year. If you look up the documentation on this function, it'll tell you all the little abbreviations to use for 2-month year, 2-digit year, 4-digit year, month, day, etc. And then I can take that string that was received when I use the input function, convert that into a date function. Now, that seems like a lot of work if all I'm doing is displaying the date on the screen. But remember, there's some really cool functions that come with the date function, things that allow me to add and subtract days and so on. That's why it's worth sometimes taking a date value that's stored in a string and actually converting it into a date time object. If all you're doing is storing it, you can just leave it as a string. But if you want to play with those cool functions, you need it to actually be stored as a date time. And that's when you're going to need that strip time. So then I can do things like say, what was the day before my birthday? So once I've converted it using that strp time function, then I have the ability to use that time delta function we saw earlier and find out what was the date 1 day before my birthday and so on. Awesome. But as soon as you start doing this in your code, you're going to want to add some exception handling, because eventually someone's going to enter a value, and the format they enter, they might enter the 30th of February, or they might enter month, day, year instead of day, month, year, and boom, your code's going to blow up. So let's make sure we handle exceptions gracefully if somebody enters a date in the wrong format, rather than having it just blow up in their faces. So error handling is also very important, and we're going to cover that in a later module. All right, let's jump into the code and see how the dates look when we use it inside our code. So if we take a look at the code I have here, this is the code that allows me to retrieve the current date and time. So you'll see here, there's a line of code from datetime, import datetime. Said we're going to talk about libraries a little bit later. Don't stress out too much about that line of code. It's basically a way of saying, hey, there's a datetime function out there. If it's pretty cool that someone else wrote for me, I want to use that. It's in a library. So this line of code allows me to use that other person's code in my code. And then I have a line here, datetime now. So what I'm doing is I'm calling the now function of datetime, and that will return the current date. And I'm storing that inside a variable. So now I have this variable current date, which contains the current date and time, and then I'm doing a print statement. And let's actually do this initially with just saying print the current date, just so you can see how that works. And go down here, and we'll run that code. Get current date dot py, and boom, code blows up. Remember, we were talking about data types and type conversions. Same things will come up when you're working with dates. So what happens is we see an error that says, I can only concatenate strings. I don't know how to concatenate date times. Yeah, I actually don't know what, 5th of June plus Susan equals, and neither does Python. So what we have to do is, just like when we worked with numbers, we have to convert the date into a string, because Python does know how to concatenate a string and a string together. So by converting that to a string, now I successfully get a message, today is, and you can now have the secret. You now know that Susan is recording this on the 10th of June, no matter when you're watching this. So another thing we can do, once we have a variable stored in a datetime object, is there's these functions that we can call that will act on the dates. And the functions are really magical. So what I've done now is I've added a second function that I want to call at the top of the line in my code. So I'm still importing datetime, but I'm calling another one called time delta. And that's a neat little function that allows me to specify a period of time, like X days or 5 days, 3 days, 1 week, 6 weeks, and so on. So I start off the same. I ask for the current date and time, and I'm putting that into a variable called today. And I'm displaying that on the screen. So this is more or less the same code we just ran. But here's the new code. I say, let's use time delta, and say, let's add 1 day. And so I say, hey, time delta, I'd like you to add a period of 1 day. So this is a parameter you pass in. I know that from looking up the documentation of the time delta function. That's how you learn how to change the values. Whether you can pass in weeks, months, you would have to look at the time delta function documentation. But what's neat is now I can actually say yesterday equals today minus 1 day. So now I can actually do math on a date value and then print that out on the screen. Or I could even say, down here a little lower, we'll comment this out for now, just to keep it simple. So now, if I run this code, Python date functions.py, you can see it says today is, I said, and I'm doing this demo on the 10th of June. It says yesterday was the 9th of June. That capability of being able to subtract and add days is really, really powerful. I once worked on some COBOL code. It was a module about 1,500 lines long that basically had to convert Julian dates to Gregorian dates to figure out if it was a leap year and things like that to basically do this. So the fact that there's a function we can call that does it for us, it's huge. It's incredibly useful if you're doing anything with dates. Let's just go back to the code. I want to show you it's not limited to days. Here I passed in days equals 1, but I could have just as easily, if we comment that out, I have a line here and I say, what if we subtract a week? So when I call the time delta function, I ask it to do a delta of 1 week. And then I subtract 1 week from today. Well, now, if I go and run that code, we can see it comes back and goes, yep, 1 week ago, if today is the 10th, 1 week ago was the 3rd of June. And it takes care of all that stuff, like was this month 30 days or 31 days, and is it a leap year, is all taken care of for me. So time delta is an example of one of the neat functions you can play with dates. There's a lot out there. Suffice to say, if you want to do something with a date, do a little searching. You may find a function that does it for you before you have to start coding it yourself. Now, when you're displaying a date to somebody, you probably need to format it. You may not always want the full date, hours, minutes, seconds, and milliseconds. So if we take a look at this code here, what I've done is I'm actually extracting just the part of a date that I'm interested in. I start off again by saying I want to use the datetime function in the datetime library because it's such a great feature. I ask for the current date and time by asking for datetime now, storing that in the variable called today. And then what I'm doing is if I ask today.day, that will return just the day portion. Today.month, the month portion, year of the year, hour of the hour, and so on. So then I can take those values and display them all on the screen. So I can access whatever part of the date that I want. You're not forced to display the full date every single time. So that way you can extract the components you need and just use the parts you're interested in. Now, sometimes when you're working with dates, you run into some interesting complications. Let's say you want to read a value that's coming out of a file or a database, or a user is giving you a date. Unfortunately, most of the time when you read a date from a file, a database, or from a person, it'll be treated as a string when it's read by Python. But if I want to use these cool date functions, I need it to be treated as a date-time data type. So once again, I'm going to have to do data type conversions. Now I need to convert from string to date. But how do I know whether you gave me the date as day, month, year, or month, day, year? And did you use slashes or dashes? All these extra complications. So I have some code here that will actually take a string and convert it to a date. What you'll see is I ask somebody to enter their birthday, so I'm using an input statement, and I tell them, please give me the date in this format. The user may not read the instructions, but I at least want to remind them the format I'm expecting. And then what I do is I use this strip time function. So what this does is it strips elements out of the string and converts it into a date time format. So you say, here's the string, birthday, that contains the string someone typed in, and then I have to tell it what format I think the date's going to be in. %D, day first, then month, %M, then %uppercase Y, which means 4-digit year. How did I know those values? I looked up the documentation on the strip time function. That's how you learn the syntax for this. Then I can print out a value on the screen, and I can use that time delta function to say what was it one day before my birthday and all those great things. So let's just try this out and see if it works. And I'm going to go ahead and run my code, input date. And it says, when is my birthday? Day, month, year. My birthday is clearly on the 6th of June, 1999. So I run, it says your birthday is the 10th of June, or sorry, 10th of June, and the day before your birthday was the 5th of June. So you can see, I know it successfully converted it to a date because I'm able to use those date time functions, that time delta. But what if the person who is running your code isn't paying attention? And they say, oh, when's my birthday? Oh, it's the 30th of February. Or maybe they just enter a valid date, but they enter dashes instead of slashes. So 10/1999. So they enter something that doesn't match that format that I'd said the date would be received in. Well, boom, here goes the code blowing up all over the place. So this is one of those situations where you know this error is going to happen occasionally in your code. So what you should do here is add some exception handling. So I think maybe we should look at that in the next module.
Now, if you're anything like me, and I know I am, the first time that I get in to write some code, sometimes things go wrong. Now, maybe whatever it is that you're doing works flawlessly, but in the real world, things will go sideways. And sometimes it will be because of mistakes that you made, things that you have control over, and sometimes it will be because something has changed, like a database has gone down, a server name has been changed, etc., where now my application isn't going to be able to accommodate that on the fly and needs to, well, potentially crash. And so let's talk about how we can deal with those different types of errors. But before we talk about how to deal with them, we should probably start defining a couple of different terms. And I want to try and make a very clear distinction between error handling and debugging, because these are two very different things. And sometimes people will use them to mean something synonymous, and they're really not. Error handling is when I have a problem with my code that's running, and it's not something that I'm going to be able to predict when I push my code out to production. The most common example of this would be a permissions issue, a database changing, a server being down, etc. Those things that happen in the wild, those things that happen in the real world, those things that I do not have control over. Contrast that with debugging. Debugging is when I know that there's a problem with my code, that it's potentially giving me a wrong answer, it's potentially crashing, and I know that there's something that I've done incorrectly that's causing my code to go sideways. That's debugging. And so when we get in and we take a look at things like try, except finally, which we'll talk about in a minute, those are not useful tools for handling debugging. Debugging, again, I've got a problem in my code, I'm trying to fix that problem. That try, except finally is where there's something that's happened external to my application that I couldn't predict that something might go sideways, and I want to be able to exit gracefully. So we want to make sure that there's a separation between those two. Now, when we're talking about errors, things that can go wrong inside of our code, these fall under three different categories: syntax errors, runtime errors, and logic errors. Let's start from the top, a syntax error. With our syntax error, our code is not going to run at all. Believe it or not, if you have to choose between the errors, this is the type of error that you want. This is typically going to be the easiest to try and track down because of the fact that, again, your code is just going to fail right then and there, and the error message that you're going to get will typically point you right to where the problem is. So if we take a look at our output, you'll notice that it's actually telling me right here, let me go ahead and circle that, it's telling me right there the line of code. And so if we take a look at our little block of code, and we'll talk a bit more about if statements later on, what we're actually missing right out here after that Y is a colon. So that's why it's giving us a syntax error, because we're missing a key there. Now, one really nice thing about Python is because of the fact that it's not using curly braces, you won't have to worry about tracking down a curly brace when trying to figure out what's wrong with your code. If you've done something like Java or JavaScript, you'll know that that can sometimes cause some problems. So syntax errors are good errors. We want those. Now, runtime errors are the second best type of error, where our code is running, something has gone wrong, and it's going to blow up. Now, in my case here, the problem that I'm going to run into is that I'm trying to do that classic divide by 0. And when we hit that line in our code, it's going to give me that error message that you see right down there at the bottom, division by 0. And it's also, very handily, going to point me at the line number where the problem occurred. Runtime errors are actually pretty decent errors because they will give me a little bit of information right up front to let me know where to start for trying to debug my code. Now, when you get a runtime error, the basic strategy here is to start from the line that it's given you and then work your way up to see where the error occurred. Now, one important tip that I want to give you here. When you're dealing with a runtime error, I'm going to guarantee you the problem is somewhere inside of your code. One of the most common mistakes that I see new developers make is they'll go in, they'll try something, it'll go wrong, and they'll make the assumption that there's a problem inside of the framework that they're using, inside of the runtime that they're using, etc. And while, yeah, it's technically a possibility, chances are it's not going to be there. So much so that you probably have better luck of hitting the lottery than you do in finding an error inside of a framework. Again, I don't want to say that this doesn't happen, but it's extremely rare. I can pretty much guarantee you that if you're getting a runtime error, assuming that it's not something like a server being down, it's an error inside of the code that you've written. Start there, finish there, that's where the problem's going to be. let's close out our conversation about try except finally with a couple last little odds and ends. First up, you'll have noticed inside my demo that I had a try except else. And that also works, where in that case, the else is going to be like I have up here, which is that blank except, where I'm just not looking for a particular parameter. Either one will work just fine. For me, I kind of like that except just because it's a little bit more consistent with a lot of other programming languages. But again, feel free to use whatever it is that you might like. Now, some final words here. I know that first bullet point might be a little bit confusing, but hear me out. Try except finally is not used to find bugs. And let's again identify what a bug is. Bug is where I have something wrong in my code, where I know that this code will not run if it follows this particular path or does this particular thing, and I have control over that. If it's something where a server might be down or I'm getting input from a user where I don't necessarily always have control over those types of things, now try except finally is perfect. But if I know there's a problem in my code, that's not where I'm going to put in that try except finally. It's also worth highlighting the fact that you don't have to catch all errors. If you're not going to do anything with it, if you're not going to log it, if you're not going to gracefully exit, then just leave it alone. I will always remember when I was working with a framework that another developer had written. What they had done is they had programmed it such that if the database threw an error, that it would catch it and then give me back some just generic error message, which made debugging my application impossible because I could never see what the original application was or what the original error message was. So if you're not going to do anything with it, just let it go. And you might be thinking, well, wait a minute, Christopher, that might crash my application. Well, you know what? Sometimes that's exactly what we want to have happen. That if our application winds up in a state where it's just flat not going to work, that's okay. Let it crash. That's exactly what crashes are there for. That's actually sometimes just fine. All right. The last type of error that we want to highlight is a logic error. And our logic error is when our code compiles properly, if you will. There's no syntax errors. It doesn't give us an error message, so there's no runtime errors. It just doesn't give us the response that we're looking for. So in my case, what you'll notice is that I've got a couple little variables here, that I've got my y equals, whoops, let's go ahead and make sure that I grab my highlighter. There we go. I've got my y being 206, or my x being 206. I've got my y being 42. And then what I'm going to do is I'm going to say, hey, if x is greater than y, then let's print out is greater than y. And now I go ahead and I run my application, and I don't get a response. And if you were listening carefully, you'll probably have noticed that I actually said the incorrect code here. That what my code is actually saying is x less than y, right here. That's what I actually wrote inside of my code. What I had meant to write, however, is if x is greater than y. This is, without a doubt, the most common error or most common mistake that I make, that I will frequently reverse my Boolean. Little side note here. I would definitely recommend taking a look at unit testing and test-driven development. They're concepts that are beyond the scope of this course, but what they're about is writing little automated tests to try and catch mistakes in your code. And they're really very much designed to catch these types of mistakes. I'm a huge fan of unit tests. Definitely recommend taking a look at unit tests inside of Python. In any event, logic errors, again, are the types of errors where everything runs, but we just don't get the right response. So how do we then start tracking all of that down? Well, if you do wind up getting something going sideways on you, and it potentially throws an error message, take a look at the stack trace. Stack trace is going to show you all of the different calls that have been made. The last calls are at the top. The most recent ones are down at the bottom. That's where your code is going to be. Look for line numbers. That will give you a perfect place to start. Now, to try and find your mistake, reread your code, check the documentation. As always, search the internet. Stack Overflow is your friend. Maybe just take a break. I can't tell you the number of times where I've been battling a bug in my code, and I just simply took a walk. Or I went home for the day, had dinner, slept, woke up the next morning, and then, that's what my problem is. Sat down at the computer, went in, and fixed it. Sometimes you just simply need to walk away. And the other big thing that sometimes you need is just another set of eyes. So if you work with somebody who does Python, have them take a look at your code. Sometimes that fresh viewpoint will be exactly what you need to try and debug your code. And that is how we can deal with the different types of errors inside of Python, and when and how to use that try, except, finally. Let's take a look at our try, except, finally. Now, in my case, I'm going to use the classic example, which is going to be that divide by 0. So I've already coded in my x, my y, and let's go ahead and print out the results. So we'll just go ahead and say x divided by y, save that, and then let's go ahead and run this. So we'll say Python, and then in my case, my demos.py. And you'll notice that sure enough, I get a little error message here telling me, hey, we tried to divide by 0. By the way, I'm putting that print above and below just to hopefully make the output a little bit easier to read, kind of separate it out from the C:\\, yada, yada, yada. OK, so now what I want to do is I want to go ahead and catch that. So I'm going to start off by saying try, and then I'm going to do that print. And actually, you know what I'm going to do? Since we're here, let's take a little look at a little Visual Studio thing. So one of the things that you're going to notice is that I have these cool little things called snippets. And what snippets will do for me is they will give me an opportunity to go ahead and get some pre-baked code where all I have to do is just simply hit tab, and it will automatically put all of that in for me. So if I choose, in my case, that try, except, else, finally, and hit tab, now it's just going to, right there, give me that whole block of code without me having to type it all in. You'll notice that that little pass is already highlighted. Pass, by the way, just simply means, hey, just go on to whatever's next. And it's used just to make sure that our syntax is still valid. So now I could go ahead and say try, print, and then in my case, x divided by y. And then if I hit tab, now I can say, what was the name of the error again? Zero division error. Zero division error as E. And then I'll just simply go ahead and say print. And in my case, not allowed to divide by 0. Tab, print, something else went wrong. And then finally down here at the very bottom, print, and then this is our cleanup code, just like that. By the way, you'll notice that I brought back up my little bit of code to take a look at. And this is honestly something that I do in the real world, that if I can't remember what the name of a particular exception is, I'll either check the docs, or I'll just simply run the code and force the error to occur. So if I'm trying to find something where maybe the server's down and I want to figure out what that error is, then I'll just simply disconnect from the network and then just go ahead and run it, or put in a garbage connection string and then go ahead and run it, and then see what the error is that comes up. Kind of a real quick and easy way to pull that up. So now let's go ahead and run this code. And now what you'll notice is we get that error of not allowed to divide by 0. and then we get this is our cleanup code down below that. And so what we saw here is how we can use that try except finally and be able to add in a little bit of error handling and do what's honestly the most common thing to do, which is to exit gracefully.
Okay, so now once we get into writing more complex code, at some point you're going to need to be able to say, when this happens, do this. When something else happens, react differently. So that's why we need to be able to handle conditions inside of our code. Basically, you'll need the ability to react differently and take different actions based on what's happening. So one of the more common situations, in Canada, we have all sorts of different tax levels depending on which province you live in within the country. In the US, it depends on which state you live in. And it also depends on the price. Actually, if you're buying fast food at a restaurant in Canada, if anything costs less than $1, you don't pay any tax on it. So when we're calculating tax, we actually say if the price is over $1 or equal to $1, then we charge a certain amount of tax. So in Python, I can handle that by adding an if statement. And you'll notice a bit of syntax here. You'll see the if statement, if, that's fairly obvious. If my price is greater than or equal to $1, then I'm going to take the following actions. Now, a couple of things to watch out for. There's always a colon at the end of your condition. That is Python-specific syntax. And the indentation here, it's not an accident that the word tax is moved over to the right here by 4 spaces. And it is by 4 spaces, not a tab. Though if you're using Visual Studio Code, it'll auto-correct that for you, so you can get away with using a tab in Visual Studio Code, but try to get in the habit of making 4 spaces. And anything that is 4 spaces in will only be executed if the price is greater than or equal to $1. Now, I'm using a greater than or equal to symbol here. There's different symbols we use depending on the condition we're looking for. I might say greater than, less than, greater than or equal to, less than equal to. The 2 most important ones, which do vary from programming language to programming language, is equal to, would be equal sign, and the not equal to in Python is an exclamation mark equal or bang equal, depending on the term you prefer to use. Now we can also add a default action using an else statement. That's a way of saying if this condition is met, set the tax to 7%, else, so if it's anything else, do the following. So if the price is not over $1, the rules in Canada state if the cost is over $1, you pay a tax of 7%, what we call our service tax. Otherwise, you don't pay the tax. So I can use that with an else statement. Again, always remembering that colon. I constantly forget that when I'm writing my code and have to correct that with the syntax error, just as you were learning syntax errors from Christopher. And again, you have to indent by 4 spaces the lines you want executed if that happens. The indentation really does change execution. I could actually write this exact same code a different way. I basically want to say calculate the tax and then print the tax out. So here I say if the tax price is over $1, set the tax to 7 and then print it. Otherwise, set the tax to 0 and print it. Or I could just say if the price is over $1, set the tax to 7, otherwise set it to 0, and when I'm all done evaluating the correct value of the tax, then go and print the tax out. Both of these will do exactly the same thing. Which one should you use? I like the one on the right. It's a little bit more elegant, not having the print statement repeating. But if it's more confusing for you, there's nothing wrong with the code on the left. Now, be careful when you're comparing strings. They'll get you into trouble. So if you run this code, and I'm just trying to see if somebody's a Canadian or not, I ask what country somebody's from, and they type in Canada. And I say if the country is equal to, remembering that double equal sign means is equal to, Canada, then print, oh, look, a Canadian. And obviously I set country to Canada, but it comes back and gives me the, no, you are not from Canada. It did not evaluate the country. What went wrong? String comparisons are case sensitive. So when you're saying, is this string equal to this string, if one's in uppercase letters and one's in lowercase letters, then Python's going to say, that's not a match. So how do I fix that? We've got to think back to, wow, the module we did a little while ago on string functions. There's a function we can use that will convert a string to lowercase or to uppercase. So what we can do is we can take the value they give us, convert that to lowercase, and then compare that to the word Canada, all in lowercase letters. So now when someone types in a value, doesn't matter what they type in, I'll convert it to lowercase before I do the comparison. And that will fix my error. So this is a great example of a runtime error that can occur and a way I can address that and fix that with my code. So conditions are very important and allow our code to react to different situations. So let's go take a look at these examples in some code before we move on to more complex types of if statements. So now let's go take a look at some code using those conditional statements in our if statements. So if we take a look at this code here, this is the code I'm using to calculate the tax rates in Canada. And as I mentioned, in Canada, you don't pay tax on an item unless it costs at least $1. So what I'm going to do is I'm going to ask a user, how much did they pay? Then I'm going to convert that to a number, thinking back to what we learned about data types and working with numbers. We want to treat this as a number, but the input statement always returns strings. So I'm just converting that price into a number here. And then I'm just going to say if that price is over $1, then the tax is 0.07, so 7%. And then I'm just going to print the tax rate on the screen. So let's see what happens if we actually try to run that code. And we're going to call Python, and we're going to call check tax. And if we pass in a price of $20, which is definitely more than $1, we should see a tax rate of 0.07. And sure enough, it comes back, tax rate is 0.07. Whereas if we enter a tax, if I paid 50 cents for something, you'll notice it does not come back and print anything out at all, because both these two statements are indented. So neither of these statements is executed unless the condition is true. So they have these 4 spaces. That's how Python knows which lines to execute when the condition is true, that indentation. Now we can add an else statement to this. So I might want to say if the price is under $1, then let's not charge any tax. So I've just added some logic here, exactly the same code, but all I've done is said otherwise with an else statement. And there's that colon. Don't forget the colon at the end of your else statement. At the end of your if statement, I'm forever forgetting that. It's one of my most common syntax errors. Then otherwise, the tax equals 0. So now, if I run this code, we'll just clear the screen and start up again. Python add else.py. And how much did I pay? If I paid $50, then the tax rate comes back as 0.07, so that's correct. And if I go ahead and I run it and I pay 50 cents, it comes back and says the tax rate is 0. Now, so now this is a little cleaner, a little more elegant, because I've got a tax value that's set according to any possible input. Now, one of the other things I mentioned is that if you wish, one of the different ways you could do this is I could write this code exactly the same by simply taking the print statement, because printing the tax rate, I always want to print the tax rate, regardless of what the tax is. The only thing that changes is what I assign the tax rate to. So in my if statement, I say if the price is over $1, set the tax rate to 7%. If the price is under $1, set the tax to 0. And then, regardless of what the final tax rate was, print that on the screen. So by taking this out of the if statement and it's not indented, that means this statement will be executed all the time, no matter what happens in the if statement. So now when I run this code, and now I enter $50, you'll still see exactly the same output. Tax rate is 7%. If I enter a price of 25 cents, you'll see tax rate comes out as 0. So the same thing's happening in my code, I'm just using a different way to achieve it. Now, there's one other example I wanted to do, and that was showing you the case sensitivity. Right now, I have a little line of code here that says, please enter the name of your home country, and if the country is Canada, then you must like hockey. Hey, I'm Hockey Geek Girl on Twitter for a reason. I am a Canadian. I love my hockey. I fit the stereotype. Otherwise, we say, okay, you're not from Canada. So if I run this code, comparing strings is the name of my file, enter the name of my country, and I enter Canada. As long as I entered all lowercase, it says, great, so you must like hockey. And I'm like, yes, you are right, Python, I do. But if I run it and I happen to enter uppercase letters, then it comes back and says I'm not from Canada. So this is a case where I have to remember that in Python, when you're comparing two strings, they're not equal to each other if one has uppercase letters and one has lowercase letters. So what I can do is I can take the value that was passed in, convert that to lowercase, and then that returns a lowercase version of what I typed in, which will match the lowercase string Canada. So now, even if I type in, whoops, I need to save that file, that would help. Just correct that. Just realized I hadn't actually hit save, using Control S to save. Now when I run it and I enter Canada, even if I enter all uppercase letters, it still comes back and recognizes that I am from Canada, so I must like hockey. So there you have it. Now let's move on and look at some more complicated situations we can deal with in conditions. So in the last module, I showed you how we could use conditions to do things like calculating our taxes. Well, it turns out calculating the taxes in Canada is a little more complicated than that. One aspect is what the price is, but we also charge different taxes in different provinces across the country. So sometimes I have multiple conditions and I need to figure out what's the correct action. So let's say you're in the province of Alberta or Nunavut, then you actually have a tax rate of 5% in Canada. And if you're in the province of Ontario, then the tax rate is 13%. So it's a big difference. You have to make sure you calculate it correctly. So I could write multiple if statements. Say, if the province is Alberta, set the tax to 5%. If the province is Nunavut, set the tax to 5%. If the province is Ontario, set the tax to 13%. This will work, but there's a more elegant way to do it. And that is using something called ELIF. Because in this case, only one of these conditions will ever happen. The province is never going to be equal to Alberta and Ontario at the same time. It's going to be one or the other. That's when you want to go with ELIF. It allows me to say, hey, check if province is Alberta. It's not? Then check the next condition. So else. So otherwise, if the province is Nunavut. Oh, what, it's not? Then check the next condition. If province is Ontario, then check that one. So basically, it'll go down the list, and when it finds one that's a match, it'll set the tax to the appropriate rate and exit the if statement right there. So the ELIF allows me to do a little more efficient way of checking code. It's great if only one of the conditions will ever be met. You still need that colon at the end of each statement. The other advantage to using the ELIF is it allows you to put that default action in there as well. So I have that ability to say, hey, for these provinces there's a specific rate, but for everybody else there's a default tax rate of 15%. So now I can just add an else statement and say, if it's Alberta, here's what you do. If it's Nunavut, here's what you do. If it's Ontario, this is what you do. If it's anything else, just set the tax to 15%. So the other advantage to VF and ELIF is I can have that default else action. Now, if you have more than one condition that causes the same action, you can actually combine those together. So in this case, Alberta and Nunavut actually have the same tax rate. So what I can do is I can use an or to say, if the province is Alberta or province is equal to Nunavut, tax should be set to 5%. So this again just saves me some time because I have multiple conditions causing the same output. I can use things like an or statement to say if it's one or the other, then give me this following output. Now the way or statements work is if the first condition is true and the second condition is true, the condition evaluates as true. What it really comes down to with or statements is pretty easy. If any one of the conditions is true, then the entire statement will be evaluated as true. So in this case, if the province is Alberta, tax will be set to 5%. If the province is Nunavut, set the tax to 5%. It doesn't matter which one is true. If any of them is true, it will set the tax to 5%. For it to say set the tax to anything else, then it cannot be Alberta or it can, and it's not Nunavut either. So it has to be neither one of them. So this is what we call a truth table that shows how the or statements are evaluated. If you have a list of values to check, there's actually a neat little shortcut for this specific situation. There's something called the in operator. And basically it's for those situations when you find yourself saying if it equals this, or it equals this, or it equals this, or it equals this. In that case, you can use something called an in. So it turns out, and this is actually true, there's actually 3 places in Canada which all have the same tax rate. So I can say if province in this list, Alberta, Nunavut, or Yukon. So if it's any one of those 3 values, set the tax to 5%. I could have done that with an or statement, perfectly valid, but I find the in statement a little bit tidier to work with. But it's up to you. Effectively, they do the same thing. Now, what about when an action depends on a combination of conditions? Let's say you're visiting Canada, but you don't live there. Well, you don't necessarily have to pay the taxes. That's that whole concept of things being duty-free when you're moving from one place to another. So we won't charge you the taxes if you're visiting. So we might need to say, hey, if the country is Canada, so if you're a Canadian making this purchase, and the province is equal to the following charge of his tax rate. But if you're not a Canadian, well, then we're going to set the tax to 0. We want you to come to the country and buy some awesome things, but you don't have to pay to maintain our roads. So you can do nesting if statements. So what I have here is I have an if statement, and inside the if statement is another if statement. Now, I'm not just making those spaces, those for space and indentation, to make it look pretty and more readable. It does make my code more readable, but that does affect the execution of my code as well. Remember, whatever is inside or indented is only executed if that statement's true. So this whole if statement of calculating the tax rate only is checked if the country is Canada. And if you are in Canada, then if the province is in this list, then tax is 5%. So in that indenting there of 4 spaces does change how the code is executed. So be very careful with that, especially when you start nesting if statements together. This might be a place where you might find it helpful to actually put that code into a function just so you don't make mistakes on the indenting. And good news, we're going to show you how to do functions soon. So we've got a lot of different real-world business rules we can handle. And the more real-world it is, it seems the more complex the conditions apply. I'm going to show you now how we would do this inside the code. Okay, let's take a look at how this works when we're actually doing it inside our code. So I have the example here. I was talking about how we have to calculate different tax rates for different provinces inside Canada. So I'm basically going to ask the user what province they live in, and I would actually do this on an online website. I would actually be looking at the province they selected when they make a purchase online. And then I'm assuming initially that the tax is 0. And then I'm saying, well, based on the province you enter, let's go ahead and assign an appropriate tax rate. And I'll just print that tax rate out at the end so we can see I'm using this for debugging purposes to make sure that I'm calculating the correct tax rate. So when I run this code, multiple call Python, multiple if statements dot py. So I run that code. It says, what province do you live in? Well, I happen to live in Ontario, so I'm going to type in Ontario. And it comes back and says, oh, 13%. And if I go check my code, yes, that is correct. It recognized that the province was Ontario, and it should be 13%. Now, this is just using a separate if statement for each. In this case, because it would never be equal to multiple of these at the same time, it would be a little more elegant if I change this to an elif. So just changing that if to elif. And it's simply a way of saying, if it's not Alberta, then check if it's none of it. If it's not none of it, then check if it's Ontario. So rather than having separate if statements, I'm now treating them as one if statement with different conditions. When I execute it, it's basically the same thing. What province do I live in? Let's type in none of it this time, just for something different. Help if I could type it correctly. And it comes back and returns 5%. If we take a look, sure enough, none of it should have returned a tax rate of 5%. So again, these print statements are helping me make sure my code is executing correctly. So everything looks good so far. But what if I want to say I'm in none of the above? What if I'm in the province of Quebec, which is an entirely different province? So I go here and I run it, and I specify Quebec, and it comes back and says if a tax rate is 0. And I go, wait a second, that's not right. So what I realize is I need to say if they're in any of the other provinces. So let's add an else statement, and let's say every other province, let's assume the tax is 15%. Now, it's not quite accurate, but close enough for the sake of experimenting in the demo. So now I run my code. I'm going to clear the screen here so you can see a little bit better. And now when I run it, now if I enter Quebec, it'll come back and set 15%. So you can see how now we've got multiple conditions we're checking. We've got the else statement and elif, so it's getting a little more elegant in our code. But there's still more improvements to be made. What I could do is I say, wait a second, none of it in Alberta are giving me exactly the same tax rate. So maybe I can combine those into one condition. And I can do that using an or statement. Because I can say if province equals Alberta, or province is none of it. So I can literally take this statement here. So if it's one or the other, don't forget your colon at the end. There we go. Then the tax rate is 0.05. So same logic again, just a different way of expressing it. So now when I go ahead and I run, and if I specify Ontario, we'll just test that. Successfully returns 13%. Let's test it with Alberta. Yep, 5%. Let's test it with none of it. correct value, 5%, and let's test it with Quebec, and correctly returns 15%. By the way, Christopher was talking a bit about unit testing and that module of exceptions. Really take that to heart. When you deal with if statements, you have to be very careful to make sure that all the possible outputs are tested, because you might find that 3 out of the 4 work, but the 4th one doesn't work. And that's the kind of stuff that gets buggy code out into production. So always test every possible condition. Now, in this situation, I have 2 different provinces that return the same output, but both of them are actually checking the same value. They're still looking in the province variable for a value. So one of the things you can do is replace that OR statement with an IN. And that allows you to say, if the value of province is one of the values in this list, then set the tax to 5%. And it turns out you can even add 4, 5, 6, 7 values to this. So you can pass in just 2 values, but I realize the Yukon has the same tax rate, so I can actually add Yukon to that as well. So now, if I run my code and I pass in Yukon, it should return 5%. If I pass in Alberta, 5%. Let's test Nunavut, because I haven't tried that one yet. Would help if I ran the code first. I'm getting ahead of myself. And then 5%, and then I test Ontario to make sure that hasn't broken. And then I test Nova Scotia, just something that's not any of the above, 15%. So again, still working, but now I'm using an in statement to do it. So I've basically just written the same code 4 different ways. This is my favorite one. I find it's the cleanest. But again, all of them are going to work. Just make sure you test for every possible condition to make sure it works. That leaves one more scenario. I have somebody from out of country ordering something on my website. If you're not from Canada, we don't charge you the Canadian taxes. So what I'm going to do here is I'm going to add a nested if statement. I'm going to ask what country you live in. And if you're not in Canada, then we aren't going to charge you a tax. So you'll see I have an if statement here. If country is Canada, then do all that complicated logic to figure out what the provincial taxes are. So then ask them what province they are and get all that information. Otherwise, set the tax to 0, because if you're from outside Canada, you shouldn't be paying those taxes. And in fact, I just realized I shouldn't even ask you what province you live in unless you're from Canada. So I might even just move that statement there. So if you're from Canada, then I'm going to ask you what province you live in, and then evaluate how much I should charge you as tax. But let's not even ask you for the province if you're not from here. Not every country is broken into provinces. So now when I run this code, oops, need to say Python nested if .py. Would help if I could type .py, Susan, that would make a difference. What country do I live in? I enter Canada. What province, state do I live in? Here we go. Because I specified the country was Canada, when the if statement ran, it said, oh, you're in Canada. I have to ask you what province or state you live in. So I go, okay, I live in Ontario. And then it comes back and says the tax rate is 13%, and that's correct. So then I need to test what happens if I say I live in United Kingdom. And it comes back and returns 0. I'm like, hey, it's working. This is great. So then I test it again, and I say I live in Canada, and it comes back and forgets to prompt me for the province. I'm like, wait a second. I was about to try and test Yukon and Alberta, but got an error. Okay, runtime errors, debugging time, and then wait. Think back to the last module. When I'm comparing strings, I have to make sure that those comparisons are case insensitive. So there we go. That's when I realized I made a little mistake in my code, and I should make my code a little more robust by checking, converting what you passed me in lowercase and comparing that to a lowercase string. Should probably do the same thing for provinces as well. So let's just see if that fixes my problem. Now I enter Canada, even no matter how I enter Canada now. Yes, there we go. It now successfully recognizes that, and I can now enter a province and get the right tax rate. So there we have it. Working with conditions, we've got nested if statements. I've got a couple more if tricks to show you coming up next, but you can see you have to be very careful with the testing as you start playing with those if statements. Okay, I have one last set of tricks I want to show you for working with conditions. There's just so many different variations we get into when we're working with conditions. So I have a couple more tricks I want to show you. Sometimes you can combine conditions with an and instead of nesting if statements. So I'm taking a different scenario this time. Let's say you've got a university or a college and you're trying to calculate which students have made the honor roll. Typically making the honor roll or a dean's list or principal's list requires having a certain average, a grade point average of a certain level, but it might also have a requirement of maintaining all your grades above a certain level as well. So your lowest grade cannot be lower than 70% and your overall average has to be 85% or higher. So I can do this by nesting if statements. We learned how to do nesting if statements. I say if the GPA, your grade point average, is greater than or equal to 85%, 0.85, then let's check your lowest grade. If your lowest grade is greater than or equal to 0.7, then that means you've met both requirements. Well done, you've made the honor roll. But I could rewrite this using an and statement, because what I'm really saying is there's two requirements here. Both those requirements have to be met for you to make the honor roll. That's what ands are for. So I can simply say if the GPA is over 85 and your lowest grade is greater than or equal to 70%, then well done, you've made the honor roll. And it's a little bit easier to read, and again, you don't have that risk of accidentally making a mistake with indenting your code. So it reduces the chance of introducing errors by forgetting to indent something. The way and statements are processed is both conditions must be true for the condition to be evaluated as true. So if we go back to this, if we had a GPA that was not over 85, let's say your GPA was 70%, well, then you are not going to make the honor roll. If your lowest grade is a 60%, you don't make the honor roll. So having one or the other isn't good enough. Both conditions have to be met for the operation to be considered true and the statement print well done to execute. Another neat trick that comes up sometimes, especially when you get to really complicated if statements, is it's useful to use a Boolean flag, because there might be 2 or 3 places in your code where you need to make that check. So rather than writing the same if statement 2 or 3 times, especially if it's complicated and you're worried you might make mistakes, or even just for readability, what you can do is you can create a Boolean flag to remember what happened in the other if statement. So in this case, I can say, hey, let's check if that GPA and lowest grade requirement was met. And if it was, I create this variable called honor roll and I set it to true. So in Python, when it sees that word true, and there's no quotation marks around the word true, this is actually a keyword in Python. That makes this a Boolean variable. And it can either be equal to true or it can be equal to false. So I say, if the conditions are met, set honor roll to true, otherwise set honor roll to false. Then you can have all kinds of code executing, and somewhere later in your code, when you need to say, oh, that's right, if they're on the honor roll, I need to send them their congratulatory letter, then I just say, if honor roll, print well done, or print them their congratulatory letter. So I don't have to rewrite all that complicated logic. By the way, you will sometimes see code that says, if honor roll equals true. You don't need to do that in Python. It's actually frowned upon. You should just be saying if honor roll, because honor roll in itself is true or false. So in terms of Python coding standards, you want to just say if honor roll, not if honor roll equals true. Both will work, but this is the accepted convention. So now we have some new options and lots of different ways to handle very complex conditions in your code. And I know I've said it before, but I'm going to say it again because it bears repeating. When you start getting into complex conditions, really do your unit testing well. Test all the possible combinations of conditions, otherwise you're going to introduce errors in your code. So let's try some of those more complicated situations outside in our code. So I've got Visual Studio Code open again, and what I have here is that example with the grade point average and the lower grade, and you only make the honor roll or dean's list if your grade point average is over 85 and your lowest grade is not below a 70. Whoops, I just realized my comments said were incorrect there. I want those to match up. So what I do is I ask somebody to enter their grade point average, and you'll notice I've done a clever little trick here this time. What I've done is when they pass me a value, the input statement always returns a string. So what I've done here is I've actually said when that string comes back, let's convert what's passed back into a float, into a number, so that I can compare it to a number in my code later. So this is called nesting functions. It's something you might see occasionally in your code, and it can be useful. If you find it confusing, you could just convert the GPA to a float afterwards, but it is possible to nest functions inside each other and do it all in one line. there's a trade-off here between less lines of code and more confusing for someone to read. So I leave it to you whether you want to do it that way, or this would be the alternative. Or I can have one way, one the other, and you can decide which you prefer. I could just say, go ask for the lowest grade, and then convert that into a float. So both of those achieve the same thing. Because the input function returns a string, I need to convert it to a number before I start treating it as a number. So these are two different ways to convert it to a number, whichever you prefer. All right, now we go ahead and we run that code. And so we call Python, and we say, let's call the using and.python. So what I've done here, at the moment I have a nested if statement, one inside the other, and it says, what was your grade point average? As long as it's nice high grade, and my lowest grade was above 70%, then I made the honor roll. So it's checked my GPA. If my GPA met the requirements, then it checks to see what my lowest grade was. And if my lowest grade met that requirement, it said I made the honor roll. But in this case, I could also have combined the two together by saying, really, to make the honor roll, there's just two conditions that you have to meet. The GPA has to be at least 85%, and your lowest grade has to be at least 70%. So this will execute the same way in terms of logic. My grade point average in this case, let's say, assume I have a nice 90% average, and my lowest grade was an 86, then I made the honor roll. I should, of course, try a couple of other combinations. What if I have a GPA of 80, and my lowest grade was 80? Aha, it does not say I make the honor roll. So again, I need to test all the combinations and make sure the outputs are as expected. Now, is there any advantage or disadvantage to using the AND statement versus nesting ifs? There can be. Let's say you had to calculate the GPA, and that was a very complicated calculation that took a lot of time. Then it might be worth just checking their lowest grade and only calculate the GPA if their lowest grade was at least 70%. Because then I'm not wasting time calculating their GPA if their lowest grade wasn't good enough. So in that case, I might use a nested if. But if you're just going to have those values and you're just checking them, then it's simpler to just do it with an AND statement. Now, in terms of writing code efficiently, another thing that can save you time and re-execution is using Boolean variables. So we talked about how if you have a very complicated if statement, rather than copying and pasting it to different parts of your code to do different things, we can remember what happened the last time we looked at the if statement with a Boolean variable. So if we take a look here, I've got that same sort of logic of let's check if they make the honor roll by meeting the GPA and grade requirements. But if they do, I'm just going to remember I'm creating a Boolean variable, and I'm setting it to true. And again, remember, this is true with not true the string. That's a string that has a value true. That would be a string variable. This is a Boolean variable. So there's no quotes around the word true or false. It is case sensitive, lowercase t. That's an easy typo to make. You'll notice it changed to black. The fact it changed to blue, the great thing about using code editors like Visual Studio Code is they give you some colors to try and give you some hints. So I can see true as a keyword that's recognized. So uppercase T for true, no quotes around it. That creates a Boolean variable. And what's neat about that is later in my code, I can say if honor roll is true by just saying if honor roll, you made honor roll. So if I run this code here, let me just run this. Boolean variables. And let's assume my grade point average was a 95. Boy, my marks just get better and better every time I test my code. And my lowest grade was an 82. Then it says I made the honor roll. But this time, you'll notice that my print statement wasn't in the original if statement. It was something that maybe happened later on in my code. So anytime you find yourself copying and pasting the same if statement to a different place, you might want to reconsider and try something like Boolean variables to make your code easier to read. But make sure you do your testing.
So we've seen how we can store individual values inside of variables. But life isn't always about an individual item. Sometimes you're going to have a group of items. And sometimes we want to be able to store them in just like a single column. Sometimes we want to be able to store them into a group where we can actually give each one a name. And that's what we're going to take a look at here in collections, where we'll introduce the concepts of lists, arrays, and dictionaries. Well, let's start with a list. A list is just simply a collection of items. So you'll notice that we've declared a variable called names, and we've set it equal to, using square brackets there. Let me go ahead and grab my highlighter. So square bracket right there, and a square bracket right there. We've set that equal to be both Christopher and Susan. Just simply put a comma between them, and away you go. And if I were to call print, you'll notice that Python will just simply print out the values that are inside of there. Now, one thing I want to highlight is that even though I've used strings, I can actually use any data type that I might want. So if I maybe have a collection of return values that I might have gotten from some external service or numbers or who knows what, I can absolutely store all of those inside of a list. Now, what happens if maybe you don't know the values in advance? Maybe you're going to be pulling them in programmatically through an input statement, performing some other calculations, or otherwise. Well, in that case, you could actually just start with an empty list, just like I have right up here. So now I've got nothing inside of there, so now I could just start adding items to the end by calling append. Now, again, in my case, I've gone ahead and just put in numbers, just for simplicity's sake. But if I was calling something external, maybe using input, all of that would work just fine. And again, if I call print, it will just print out just like we saw before. But I do want to highlight the fact that we can access individual items inside of a list by using an indexer. Now, if I say scores, and then that's square brackets of 1, what it's actually going to give me back is the second value. The reason for that is because everything in Python is going to be 0 indexed. So all counting starts with 0. Python also has arrays. Now, in order to use an array, it's slightly different syntax. You'll notice that we have to import in our arrays. We saw this a little bit with datetime, and we'll talk a bit more about this later on. But that allows me to get in my array. And then what I do is I declare the type of array that I want. In my case here, I'm declaring an array of digits. And that's what that D stands for. If you check out the GitHub repository for this course, you'll actually notice there's a link to the documentation where you can go in and see all of the possible values for all the possible data types that you can put into an array. Now, you'll notice from here, the code winds up being basically identical. I want to add numbers? Fine, just call append. I want to print? Fine, just call print. And if I want to access an individual item? Fine, just go ahead and use the exact same indexer, and I get the exact same results. Just some slightly different formatting things, just because that D is actually going to be floating point. And you might be wondering at this point, well, wait a minute, Christopher. Then what's the difference between an array and a list? Well, an array is designed for simple types, such as numbers, and all the items inside of there have to be of the exact same type. A list, on the other hand, can actually store any type of item that you might want, which is why I've actually represented it with a shopping cart. You can kind of think about it that way. You just toss whatever it is that you might want inside of there, and it's going to then keep the list of all of those different items. You'll find in most of the code that you're going to be writing that you'll be working with lists unless you start getting into a lot more machine learning. Then when you get in and start programming your own ML models, you'll find yourself quite frequently working with larger types of arrays there. Now, what else can we do with arrays besides find individual items? Well, we can go ahead and grab the length of an array by calling len. We can call insert and specify where we want to put something inside of an array. And in this case, it's going to wind up going in just before the index that we specify here. So since I specified 0, it's going to go at the very beginning. And then last but not least, I also have the ability to call sort, which in my case here is going to wind up doing it alphabetically. So when we run this, you'll notice that it will tell us that we have 2 items to start because we didn't insert Bill in. Then when I call insert and then I put in Bill, it's going to put it at the very beginning. And then finally, when we call sort, you'll notice that it will automatically do this in alphabetical order. The last main operation that we want to highlight with a list or an array is to get just a subrange. And the way that we do that is by indicating this syntax right here of that 0:2. There's two parameters. The first parameter, let me grab my pen here, this is where we want to start. So we're going to start at the very beginning. That's our 0. The second one is how many items are we going to grab? So in our case, we're going to grab 2 items from the beginning. And so now, if we take a look at our presenters here, which is that second list, what you're going to notice because of the fact, let me make sure that I've got my pen. Now I do. Because of the fact that we grabbed that as the subarray, and when we print that out, you'll notice that it just gives us the the first and the second items there. We start at 0, start with the first item, and then grab the next 2. And so that allows you to grab just a smaller set of values that might be inside of a list. Okay, now the last type of collection that we want to take a look at is a dictionary. Now, if we take a look at the syntax for setting up a dictionary, you'll notice that this very closely resembles JSON if you're familiar with JSON or JSON. If you're not familiar with JSON, don't worry. We actually have a module coming up a little bit later where we'll talk about it. Now, with a dictionary, what we're going to have is key value pairs. So we'll have a key of first and a value of Christopher. And then we'll go ahead and add on another value with a key of last and then a value of Harrison. You'll notice that we could print out the entire dictionary. And you'll also notice that if I want to go grab an individual item, that I can do this by using the name rather than by using the index. And so the eventual result here when I print this out is it's going to tell me first Christopher, last Harrison, and then you'll notice that when we just called person first, that it's just going to print out Christopher. You might be wondering, okay, well, when should I use a dictionary and when should I use a list? Well, in both cases, I can put in whatever values it is that I might want. The big advantage that a dictionary gives to me is it gives me a set of key value pairs. So if I need to be able to go in and find a specific item, and I don't necessarily remember the order of it, that's perfect for a dictionary. Or sometimes just the ability to name something is exactly what you're looking for. Again, you'd be looking for a dictionary. Now, if I want to be able to access it based on a numerical index, or I need to guarantee the order of all of those items, that's where a list comes into play. So with a list, everything's going to be number indexed, and it's going to guarantee the order of items that go in and the order of items when I go to pull them all back out. Let's get in and take a look at some code samples for our lists and for our dictionaries. Let's start off our demo by taking a look at how we might create a dictionary. So what I'm going to do is I'm going to start off by setting this up as an empty dictionary right here. And now I can go in and start populating it with whatever it is that I might want. So I can say person and then first equals Christopher. And then I could say person last and then set that equal to Harrison. And I could also just do this in one line. So let's actually do it this way. By the way, cool little Visual Studio trick. Highlight an item, Control D, and that will select all of them. And then I could change them all in one shot. So I could actually then just call this Christopher, just like that. Cool. So now let's put in Susan's here. So let's say Susan. And let's just do this all in one shot. So we'll just go ahead and say first, and we'll set that to be Susan. And then we'll say last, and we'll set that to be IVAC, just like that. Cool. So now if I go in and I say print Christopher and I say print Susan, now what you're going to notice is that it will print out both of those items there. So there's Christopher and there is Susan. Now, just because I have decided to put both of these inside of dictionaries doesn't mean that I'm precluded from putting them inside of a list, which is kind of cool. So I could actually say presenters, or people maybe, equals create a list, and then we'll say Christopher, and we'll say Susan. And so now, if I print out my people, and we'll just put in a closing print down at the bottom there. Let me make sure that little bit of IntelliSense goes away. Go away. Thank you. There we go. That way you can see the code a little bit better. Now what you're going to notice is it prints out Christopher and it prints out Susan inside of that one list. And that gives me the opportunity to really drive home the point that when you're working with a list, you can actually store any type of item that you might want inside of there, including dictionaries. And you'll also notice that I'm using a dictionary much in the exact same way that I would use an object. Kind of a very similar bit of functionality there. I could also go in and add in somebody. So let's just do this. Let's just go ahead and say people.add, append. Sorry, there we go. That was what I was looking for. And let's say first Bill, and then last, and we'll say Gates. There we go. And now let's go ahead and run that. And now you'll notice that we've added Bill Gates to the very end there. And if I want to go grab our presenters, just like we had before, now I could go ahead and say presenters, and let's set that to be people. And in my case, again, I'm going to start at 0, going to grab 2 items. And now let's print out our presenters. There we go. Going to put all of the code onto one screen so that way you can see that. And now when I run this, it gives me my people up at the very top. You'll notice the full list. And then when I print my presenters, now you're going to notice down there towards the bottom, it's just Christopher and just Susan there, because again, we restricted that list to just the range. I also want to highlight here that when I do this, when I go in and I say people 0:2, I get that range, it does not modify that list. It creates or returns a brand new one. Last little thing, let me just go in and comment this. I want to highlight this one more time. I know I had it on the slide, but it bears repeating here. And let's just say presenters, and let's rerun my code. The way that you get a length of a list is by calling len, calling that len function. This is one of those that always throws me, because in a lot of other languages, it's typically a property. So you would typically say the name of the list or the name of the array dot length or dot count, and that would give you the value back. In Python, you call that len function and pass that into there. So in that demo and in this whole section, we saw how we could use lists. We talked a bit about arrays. We saw dictionaries, and actually how we could bring all of them together. Let's introduce the concept of loops in Python. One of my favorite things about Python is they do a fantastic job of going, hey, these are all the different things that you're going to need, and not necessarily overloading you with a bunch of additional things that you don't necessarily need or could live without. And I think nowhere else is this more true than when we're talking about loops inside of Python. Now, what you're going to notice with loops inside of Python is there's really actually only 2. You'll notice that there's a for, which honestly acts like a for each if you're familiar with that from other programming languages, and there's a while. There's no concept of an until. There's no concept of maybe putting the condition at the end of the loop or anything like that. Because honestly, in almost every case, there's other ways that you could write that without needing the extraneous syntax. So I love this about Python, that it's like, hey, this is the tools that you're going to need. Let's not overwhelm you with a whole bunch of other ones where you're then trying to figure out, okay, well, when do I use this and when do I use... It's really nice that way. So let's start off by looking at for loops inside of Python. So there's the syntax. So what we're going to do is we're going to say for, and then some variable right here. So we'll say name in, and then our list. Now what will automatically happen behind the scenes is the first time through, name will be Christopher. And then the second time through, name will be Susan. That's it. It'll just automatically go through that list for us, and each time it finds a new value, it'll put it inside of name, and then I can do whatever it is that I might want with it. As with keeping with all of our examples, we'll just print it out to the screen. And so there is my names of Christopher and Susan. If you have a list of items and you use that for, that's perfect. But you might be thinking, hey, wait a minute, how do I then loop X number of times? Well, the way that you do that is by using a built-in little function called range. What range will do for you is it will automatically create a list of numbers for you, where this right here, let me just change my color, that little 0 right there, that's going to be the starting number. That blue really isn't. Let's do it this way. There we go. We'll just circle it. That right there, that's going to be our starting number. And then the second parameter is going to be the number of items that we're going to get. So if I go in and I run this, what you would notice is it will then print out 0 and 1. So it behaves the exact same way that we saw before. It's still going to do that for loop. The only difference really is that when we call range, it's just automatically going to create that array of 0 and 1. And yes, I know it looks like a 4-year-old drawing on the screen there, rather than, well, however old I am, but you sort of get the picture there. So if you want to loop a particular number of times, then you use range for that. Now the last loop that's available to us is a while loop. Now with a while loop, what we get to specify is some condition. So as long as something is true, so in my case, index is less than the length, we're going to stay inside of that while loop. Now the catch with a while loop is you have to change the condition. At some point, this needs to test as false. If it doesn't, you're going to be stuck in there forever. You'll wind up getting a Stack Overflow error. So you need to make sure that you change the condition. And in my case, I'm doing that right here at the very bottom, where I'm adding 1 to the index. Now, this is the example that I'm using, and this is probably the most common example that you'll see when people are introducing loops. But I have to be honest with you. This is not a typical example of a while loop. Typically, you would want to use a while loop in situations where something is going to change automatically. So if I was maybe reading through a list of lines inside of a file or something like that, that's perfect for a while loop. In this example here where I've got a list, I'd really want to use a for loop almost always. If I maybe wanted to go like every other item or something like that, then maybe I go in and I use a while. Or if I'm looking for something, then maybe I would use a while. But most commonly, what I'm going to wind up doing here is really just using a for loop. In any event, let's get in and take a look at some examples of a for loop and a while loop. Let's see how we can use for loops and while loops. Now, in my demo, I'm actually going to be looking for the exact same output in both, just to be able to compare and contrast and how you might will use one versus the other. So let's start with our for loop, and we'll say for, and then again name, in, and then people. And by the way, let me get rid of that real quick. And let me put in 4, and one more time highlight the little code snippet. So if I hit tab here, target list, and my expression list, so my target is going to be name, my expression is going to be people, and then now my code, I'll just simply say print, and then the name. Cool. And so now, let me just hit escape to get it out of that mode. And then if I say my little py, and then demos.py, and now I get an error message because I don't know how to spell people. That's OK. Let's go ahead and fix that. I should have noticed the green squigglies. And now you'll notice that I'm getting Christopher and Susan there. Let me just put in a real quick print before and after, hopefully just to make that a little bit easier to see. There we go. Voila. So there's Christopher and there's Susan. OK. Now if I was going to do the exact same thing, so I'm not going to print it out the second time, but do this instead with a while loop, here's how it would look. I'm going to say index equals 0, and I need some form of a counter. And then I'm going to go ahead and say while, and we'll say index is less than the length of people. And I always like to do this. If I'm going to do a while loop, I always like to make sure that I'm putting in the change right away. So I'll go in and say index equals index plus 1. And now let's come back up one level. And now we'll go ahead and say print. And then we'll say people, and then our index. Cool. So there is all of my code there. And now if I run this, now what you're going to notice is I get that exact same output of Christopher and Susan. And so in the end, that for loop and that while loop do the exact same thing. Let me get that uncommented. There we go. So they do the exact same thing. And like I said at the outset, you really can choose either one. For something like this, I personally would prefer using a for loop just because I'm going to miss incrementing index. Guaranteed. So I always try to put that in right away because otherwise I will forget it. But that's how you can do for loops and while loops inside of Python.
So now we've started learning a lot more syntax and things we can do inside our code. Now I want to show you one of the ways you can write your code more efficiently. And that's done by using functions. There's a lot of times, because let's be honest, as coders, most of us are pretty lazy. And I know I'm extremely lazy when I write code, and copy and paste is our best friend. And so you will often find yourself copying and pasting code from one place to another. So in this case, I've got a fairly simple program, and maybe I've been trying to figure out why my program's taking so long to run. So I've written some print statements inside my code to just tell me what time it is when the code is running, so I can see what time it is at different stages in my code. So I've just copied and pasted a few lines of code that just print out the current date and time, so I can see, that my print statement didn't take so long, the for loop, how long that took to execute, and so on. So just a little trick I was using to try and debug my code, figure out what was taking a lot of time. So at first glance, it doesn't take me long to do this. I just copy and paste the code. But as soon as you find yourself copying and pasting the exact same lines of code to more places in your program, pause and ask yourself, if I'm copying and pasting that code, maybe, just maybe, I should move that into a function. Because if you're running the same code over and over again, you can put it into a function, and then every time you need that code to run, you can simply call the function instead. So what I've done here is you'll notice I've created a function called printtime. So I've defined the definition of the function with that def statement. So define a function called printtime, the parentheses on either side after the name, and then a colon. That's the syntax for declaring a function. And then you write the code that you want executed every time you call the printtime function. Be careful with the indentation. Again, it needs to be indented by 4 spaces. Just like when we were working with if statements and loops, the indenting determines what code belongs to that function. Then, back in my program, when I want to execute those statements, I just call the printtime function. And this executes exactly the same way in terms of how the logic is executed. So what's the advantage if the resulting code execution is the same? What do I get out of moving this into a function? The real advantage here, well, there's two. One, it makes the code more readable. If you actually take a look at the code, you'll see things like I'm calling print time. It makes it very clear what's happening on this line of code. Here I'm calling print time, here I'm calling print time. So if you use good function names, it almost makes the code more readable. But the really big advantage is, at some point you go, hey, you know what? Maybe there's a better way to write that code. So up here you'll notice I imported datetime because I wanted to print out the current date and time. Think way back to the module we did on dates and times. There was actually, you'll notice when I call datetime, I have to call datetime.datetime.now. Oh, because I'm saying in the datetime library, call the datetime object, call the now function of that datetime object. It's pretty clunky. Back when we looked at the datetime function, there was another way of calling this, and we'll discuss this more in the upcoming module on libraries and modules. You can say import from datetime, import datetime. So I can say, we'll explain what that means later, but that just allows me to say print datetime now. So I go, ooh, I've learned more about Python. I found a cleaner way of calling that now function. So now I only need to update it in one place, right inside the function. Because otherwise what tends to happen is when you copy and paste code and then you find a mistake, we tend to forget to update it everywhere, and we might update it 2 out of 3 places or 1 out of 2 places. By moving copied code into a function, if I need to change something, I only need to change it in one place. That's a huge benefit of moving your code into a function. Now, sometimes we copy and paste our code, but we change it a little bit when we move around. In this case, I might have different messages I want displayed each time. So if the code is the same, I want to display a message in the timestamp after certain chunks of code, but I want the message to be specific depending on what command I was running. So can I still use a function? Sure you can, because when you use functions, you can pass in parameters. So what I can do is when you call the print time function, just pass in a task name. I just made up the name for that parameter. You can make up your own parameter names, just make them meaningful so it's easier for somebody to try and guess what values to pass in. And add some comments to it. Make sure you put some comments to explain what the function does. It'll make it easier for you to remember later and for other programmers to understand your code. Now, if you do have a parameter for the function, then when you call it, you have to pass in a value for that parameter. So you can see here, when I call print time, I pass in first name assigned. So now when this function runs, wherever you see task name, it will have the string first name assigned. So that way I get the message I want when I want it. I can control it each time I call the function. So parameters allow you a lot more flexibility when you're creating your functions. Here's another example where the code looks slightly different, but I'm actually doing the same logic over and over again in my code. So again, maybe a copy and paste scenario which I want to clean up and do more efficiently. So I've decided I want to figure out someone's initials. Maybe I'm working for a company where we are generating user IDs for somebody who visits a website or a default email address, and we use people's initials to generate that user ID or default email address. So what I do is I use the first name. I take the first name that they pass in, so I ask them to enter their first name, and then I extract, and this is one of those tricks if you remember the module we did on lists and we learned how to extract values from a list. I start at position 0 and I ask for 1 character. So that's asking for the first character of their name. And I'm storing that in a variable called first name initial. Then I ask the user to enter their last name. And then I take the last name, I start at position 0, which would be the first letter, and I count 1 letter. So that'll extract the first letter from their last name. Put that into a variable called last name initial. And then I use that, in this case I'm printing it to a screen, or I could be using that to generate an email address or a user ID for somebody. So the code at first glance doesn't look the same, but if you think about the logic that's happening, both the highlighted lines of code are achieving the same task. They're taking a string and asking for the first letter from that string. I can move this to a function as well, but it's going to be a slightly different syntax, because now I want to have a function which accepts a value. So I define a function called getInitial. It accepts a parameter name, so you pass in a name. I will give you back the first letter of that name. So I say take the name, extract the first letter from it, put it in a variable called initial. But now what I'm doing is I'm actually adding a return statement to my function. So this function always passes back a value. Now that's going to change the way we call it, because since the function will pass a value back, that means when you call the function, you have to have a place to put the value that gets passed back. So you'll notice in the code that when I call the program getInitial, and I pass it first name, I say take the value passed back and store it in the variable first name initial. And when I call it here, I say call the getInitial function, pass it a last name. When the value is passed back, it'll be stored in the variable last name initial. So same programming logic, but by using functions, again, I'm making the code a little more efficient. And I still have that wonderful advantage that if I discover later I want to change something in the code, like, hey, wait a second, the initials came back lowercase. What if I want those initials to always be forced into uppercase? All I have to do is change one line of code in the function, and it's fixed everywhere. That's one of the biggest advantages of using functions. Readability, and the fact if you need to make a fix, you only need to change it in one place. Now, the other thing that's neat about functions is you will sometimes see coders getting very clever with them. Because they return values, you can call them different ways. You can either call them and take the value that you receive and return it into a variable, or you can actually call it directly inside statements. So here what I've done is I've actually moved the function calls. So I have a first name, entered by a user, a last name, entered by a user, and then I just say print your initials are, and right inside the print function I call the getInitial function, which returns the first letter, and then concatenates to that, call the getInitial function, passes me the next letter, and prints it out. Some people look at this and go, oh, that's cool, I love it, it's great. Very efficient, one line of code, I didn't have to declare extra variables. Other people look at this and go, okay, now I'm confused. So really it's a trade-off here. It's kind of up to you if you prefer to nest your functions inside other calls, or whether you prefer calling them explicitly and putting the values into a variable. You're going to see both examples when you're looking at blog posts and tutorials, so it's good to be aware of the two options. But when you're writing your code, it's up to you. So functions really do make your code easier to maintain and more readable if you use good function names and good parameter names. Always add comments to explain the purpose of your function. So with each function declaration, always include some comments saying, this is a function, this is what it does. If it has parameters, add comments to explain what each parameter is for. It'll make life easier when you have to come back to your code later. And that define function has to be declared in your code before you have the code that calls a function. All right, now let's go try it out in Visual Studio Code. So let's try using some functions inside our code. If we take a look at here, I've got that simple code we were doing in the explanations, where I've copy and pasted 3 lines of code. So I have display a first name, and then I'm printing a statement because I want to see how long my code is taking to run, and I want to check the timestamp at different points in my program. And then after this command completes, I also want to print out the current date and time. So this code runs just fine. And we'll execute that so I can show you the output that comes back. Python print time with repeated code. So when I run that code, you can see that it is successfully, and I'll just move this up so you can see the full output. So you can see it's displaying task completed, current date and time, and all the outputs. All right, but said, it's just I've copied and pasted code. So it's the same code over and over again. I can just take that code, move it up here, and add a function called printtime. Don't forget a colon at the end of your function definition, and that def means define the function called printtime, and just paste my code here. I do need to make sure that's indented over 4 spaces. All right, and now everywhere I was calling those 3 lines of code, I can simply call the printtime function. So here and down here, and I should see exactly the same output, except now I'm not copying and pasting code. So I've just added the function call now, and every time you call that function, these 3 lines of code will be executed. So we'll save that. We'll go down to our terminal here, rerun our code, and sure enough, you can see, let me just expand that again so you can see, once again we're seeing exactly the same output displaying. So I'm seeing the task completed, then it's running through my loop and displaying the task completed and the current date time again. Now, this has the advantage, I should definitely go and add a comment here, This is a function to print current date and time. So I always want to make sure I add comments with my functions. Now the nice thing about this is if I go, hey, wait a second, I learned a better way to call datetime. I don't like this datetime.datetime.now. That always confuses programmers. So I'm going to improve the way I access that library. And we're going to learn about libraries in an upcoming module. And then I can just say datetime now. There. That's cleaner code, easier for somebody else to read. So once I learn a little more about Python, I can make my code better written. But I only have to change it in one place because now, of course, anytime I call the printtime function, it's already there. Now, what if I decide, hey, I want to display custom messages? So a different message depending on what task just completed. What I can also do is I can add parameters to print time. So I can say, hey, every time you call print time, you tell me which message you want displayed. Right now, it always displays the message task completed. So I might say, tell me the task name that you want displayed. And then every time that you do the print statement, it says whatever task name you pass into me, that's the message I'm going to print on the screen. Now, if I do that, I have to make sure that every time I call the function, I give it a value. So this is printed first name. That's the task it just completed. And here, this is completed for loop. So when you put parameters on a function, you have to pass in values for it. We'll save that, and we'll run. And what we'll see this time is that the message varies each time it's called. So I see when it printed the first name, there's the call, my message that I requested, and the current date and time. Then my loop executes, and we called the print time function with the message completed the for loop and the date time. So that gives us more flexibility in more ways of using our function. So just because something's a little bit different, you might be able to use a function with parameters. Now, the other thing we do sometimes is we might have more complicated code. For example, I'm just going to bring up a piece of code here. Let's take a look at this getInitials program. So what this one does, and I'll just collapse this pane so we have focused on the code, is we ask somebody to enter again their first name, their middle name, and their last name. And from that, we extract the first letter from each name. So we take the first name that they enter, and we go to the character position 0, get the first letter. Then we do the same thing with the middle name and the last name, and from that we can return their initials. So if I run that code, then you can see how that works. It's going to ask me to enter, oops, I forgot to enter the file extension, .py. My first name is Susan, middle name Jane, last name Ibach. And it comes back and says my initials are SJI. So this code works fine, but again, I've got almost exactly the same logic happening over and over again. So there's another opportunity to be more efficient and readable in our code by using functions. So I'm going to go up here and I'm going to define a new function called getInitial. And when you call it, you pass in a name of some sort. And what I will do is I will get an initial back, and the initial equals whatever the name is you passed in, and go from character 0, which is the first letter, and retrieve one character. But what I'm going to do is a little different here is, in this case, I actually need to pass a value back to the person that called the function. So I say return the initial. There we go. So now I've returned the initial. So what I can do now is, everywhere I was trying to extract it, I can simply say, whenever I need an initial, call the getInitial function, and pass in the name whose initial I want to extract. So everywhere I was doing that logic, I replace with a function call. GetInitial, middle name. There we go. And here we go. This one here, we're going to change this to getInitial last name. Save that. And when I execute the code, it should work exactly the same way. Enter my first name, middle name, last name, and it comes back with the initials SJI. So what did I really gain from doing this? If you take a look at the code, I think it's a little more intuitive to see that calling getInitial makes it clear I'm retrieving an initial back. Up here, I should add some comment here. It says this function will return the first initial of a name. But what's neat about this is I can do things like go, oh wait, I've had that problem with the initials returning in lowercase. If I need to fix that, then all I need to do is go to my function, make the fix in one place, say when we return initial, let's make that uppercase, and suddenly that code is fixed everywhere that I was calling it. So now, first name, middle name, last name, it doesn't matter, all of them return the initial in uppercase. So that's, to me, the real magic of functions. Makes the code a lot easier to maintain. Now, there are some other neat things we can do with parameters, and I'll show you that in the next module. So now you've learned how to create basic functions. Let's look at how we can play with the parameters we pass into those functions, because there are a few things we can do in that space. You already saw that we can create a function which accepts a parameter and that can return values. So just to review, we'd seen we created a function here called getInitial. When you call getInitial, you pass in a name. So here we have the call in our code that's calling getInitial, and it passes in a first name. Whatever is passed in gets used in the code wherever you see the word name. And when this function is completed, it returns a value. And that value that's returned, when I call the function, I have to have a place to put it. So in this case, when I call getInitial, the value I receive back from the function gets put into the variable first name initial. All right. One of the things I'd realized in my last one when I was writing this function is that, maybe if somebody enters their name in lowercase letters, I still want initials to be returned in uppercase letters when maybe if I'm using this instead to create a user ID or an email address. So I've added this .upper here to always make sure the initial returns in uppercase. And that, I think, makes a lot of sense if we're using it to extract initials for a user ID. But what if it's an email address? Email addresses I don't always want uppercase letters. So sometimes I want you to be able to say, make it uppercase, but maybe not always. Well, that's okay, because I can actually pass multiple parameters to my function. So what I can do is I add a second parameter called force uppercase. And when you call my function, you tell me whether you want false, don't force the initial to be uppercase, or true, do force the initial to be uppercase. And then inside my function, I say, if you've said I want it forced uppercase to true, then return it forced uppercase, otherwise whatever case was passed in. So you can pass multiple parameters to a function, but make sure if you do have multiple parameters, make sure you pass the parameters in the order they're declared. So you'll notice I have the parameter name and the parameter force uppercase. When I call it, I pass in the first name, the value for name, and I pass in false, the value for force uppercase in that order. So now I have a little more flexibility in what I can do with my function. It can get a little confusing though when you're worrying about the order in all these different situations. So we'll see some more tricks we can do. One of the things we can do is we can specify a default value for our parameter. Now what's neat about this is I might say, most of the time you probably want me to always return initials in uppercase. So what I'm going to do is say that the force uppercase is defaulting to true. So what that means is if you don't give me a value for force uppercase, I'm always going to say true for force uppercase. So now when I call the function, in this case you'll see I didn't even pass in a value for force uppercase. I can pass in a value if I want to. I can pass in a value true, I can pass in a value false, or I might just say, you know what, I'm going to give you a value first name, just use the default for the other parameters. This is another one of those things you'll see a lot when you look at tutorials and blog posts. You'll be like, how come over here when they call it, they passed in 4 or 5 values, and over here when I called it, I only passed in 1 value? What's going on? What's happened is the person who created the function has some default values for the parameters. And it may be that the default values work fine for a certain situation. So when you're calling a parameter or looking up documentation for functions, take a look and see if some of the parameters have default values. If they do, that means you don't have to pass in a value for them. It's optional. Something else we can do that I find is a really good habit because it makes your code a lot more readable is to do what's called named notation when you pass in parameters. Earlier I said you have to pass in the parameters in the order in which they're defined. So if I have a parameter name in force uppercase, you have to pass me in the name and then the value force uppercase. That was only a half-truth. If you're using what we call positional notation, meaning the position of the parameters lets the function know which parameters go with which values, that's what you have to do. But there's something else called named notation. And what that does is when I call the function, I can say, hey, for that parameter force uppercase, I would like you to set a value to true. For the parameter called name, I would like you to use the value of first name. So in this case, doesn't matter what order I specify them in, because I'm telling the function, here's the value for force uppercase, here's the value for name. By naming the parameters, it doesn't matter what order I specify them in. And I still have an option if there are default parameters, default values for the parameters, they're still optional to specify. What I love about doing it this way, all executes the same, is how much easier it makes your code to read. I have done a lot of systems where we had to log errors when things went wrong in our code. And you would sometimes see code like this. Somebody creates, one of the coders on our team creates a function that we pass it the error message and the error code and what time the error occurred and all these parameters. And it would then say, ooh, if that's the error that happened, I'm going to log it in this database over here and put it in this file with all these particular actions. And you'll see calls like this in the code. Somebody calls the error logger and it says, ooh, call error logger, pass in the values 45, 1, true, second number greater than first, my math method. Okay, I'm not sure what those values are telling me, but I guess that's the right values. So if I'm, told later I need to go fix this person's code, I get really confused when I read a statement like this. What if I rewrite that a little bit and I use the named notation here? And suddenly it says, call the error logger, pass in an error code of 45, an error severity of 1. Log to database, set that to true. The error message is second number greater than first, and the source module was my math method. Oh, suddenly I can almost guess what the values are I should pass in whenever I call error logger because of this named notation. So it's a really useful trick and makes your code much easier to read for yourself when you come back to it later, or for someone else who has to try and understand your code. So the named notation makes your code a lot more readable. Let's go try this out in some code. All right, we just saw how we can use parameters in our functions. Let's try that out in some actual code. We're actually going to start with the same function we were using at the end of the last module when we were talking about functions. So I've got this getInitial function, you pass in a name, it retrieves the first character of that name, converts it to uppercase, stores that, and then returns it to whatever called that function. And if you look at my program itself, I ask somebody for their name, and then I call the function and say, hey, they just gave me a name, please give me back the initial for that name, store it, and print it on the screen. So just to show what's happening here, let's just call that code, getInitials function.py. There we go, it asked me for my first name. Even if I type it in lowercase, it comes back and says, your initial is S, and returns it in uppercase. But what if, and I think that makes a lot of sense if I'm trying to generate user IDs, might be based on someone's initials, always uppercase, but if I'm using it to generate an email address, maybe I don't always want it to be flipped into uppercase. So let's add a second parameter. Let's call it force uppercase. And now what we'll do is we'll say, hey, when I call this, if force uppercase is true, now that's a Boolean variable, so I don't have to say equals true, I just say if force uppercase. We learned this in the module on conditions. Then let's return the initial in uppercase, but if they didn't, then let's return the initial, but not convert it into uppercase. So if they give it to me uppercase, it'll be uppercase. If they give it to me lowercase, it comes back in lowercase. Doesn't matter. So now, but because I've added a second parameter to the function, that means every time I call it, I have to make sure I pass in a second parameter. So here, where I call it, I have to pass in a value true or false. Let's actually pass in a false this time. So this time, if I pass in my name in lowercase, it should give me back the initial in lowercase. So I pass in false, and I run the code again, and oh, I made a typo. Oh, I forgot. Syntax errors, they're always going to happen. This one gets me all the time. I forgot to put the colon after the word else in my if statement. So let's just run that again. And it says enter my first name, Susan, and it returns an initial of S. So we said don't force it into uppercase, so now we have that control. I can get it back in uppercase or lowercase. I decide when I call the function which one I want back. So more control with my code. Now another neat thing you can do is you can specify a default value. So if I say, let's assume they want it back in uppercase if they don't tell me otherwise. if I just make that change and call the program again, I can still pass in a value for force uppercase. So I can still say, no, I don't want it to force it to uppercase. So I pass in a value of false. And sure enough, when I run it, if I pass in my name in lowercase, it returns the initial in lowercase. But because I specified a default value, I have the choice of not passing a value for uppercase at all. So I could just pass in the first name and then say, hey, forced uppercase, you've got a default value for that, just use that. So in that case, now whenever I call it, and I pass in my name in lowercase letters, it says, oh, you didn't give me a value for forced uppercase, so I'm going to use that default of true, and when it's true, I always return the initial in uppercase, so you'll notice it comes back and gives me back the initial in uppercase. So default values, it said, great, makes it easier for other people to call your code. The other thing I mentioned was the fact that we can use named notation when passing in parameters. So I can, when I'm calling this, I could actually say force uppercase equals false, and first name equals, or a name equals first name. By default, when you call a function, it assumes that the first value you pass in goes in the first parameter, the second one goes in the second parameter, so on. But when you use a named notation, it achieves two things. It makes your code easier to read, and it means you can pass in the parameters in any order. So in this case, you can see, even though I pass in name in lowercase letters, it returns it in lowercase because I said to use force uppercase set to false. So named parameters or name notation is a neat way of calling the functions to make it a little easier for others to read.
In the last module, Susan introduced how you can create functions which give you a level of reuse and readability. Now, let's say that you decided to take a handful of functions that you've created, and now you want to be able to reuse them inside of your current application, or maybe even in different applications that you're going to be creating. Well, the way that we do that is by utilizing modules, and how we can import them into separate projects is through the use of packages. Well, let's start off by taking a look at how to create a module on our own. So if you take a look at the little slide here, what you'll notice is that we're introducing the concept of a module. And a module really is nothing but a Python file with some functions, maybe some classes or other components that you're going to be able to reuse. Why set them up? Well, because it gives you the opportunity to break down your code into that reusable module structure and helps make things a bit more readable as well. Now, to create a module, it's actually pretty easy. All that you need to do is just create a file. In my case, I'm naming it helpers.py, and then add in your appropriate code. And so if you take a look at the function that's here, there's actually nothing that's special about it. Susan showed you how to do something exactly like this in the prior module. That's really all there is to creating a module. Now, when it comes time to use a module, then what we need to do is we need to import it. Now, there's a lot going on this slide, but the big thing that I want to highlight here is the fact that I'm actually doing the exact same thing. I'm just doing it 3 different ways. And depending on how you do it, it'll have a slightly different impact on your code. There is, however, no performance difference whatsoever. It really is simply a matter of how we're going to gain access to whatever happens to be inside of our module. So you'll notice here, if I grab my highlighter, that first little section here, I'm going to import in helpers. Helpers is the name of that Py file that we created. And if you remember, there was a display function inside of there. And so in order for me to now call that display, now that I've imported in helpers this way, I simply say helpers and then .display. So what the above line of code did is it automatically pulled in all of the functions and made it available inside of a little collection, if you will, or inside of what's known as a namespace called helpers. So anytime I want something that's going to be inside of there, I type in the name of the namespace, in my case helpers, dot, and then the name of the function that I want. Now let's say that I want everything that's inside of there, and I don't always want to type in helpers. Well, the way that I do that is by just modifying my from statement. So this, or my import statement. So this time what I'm going to do is I'm going to say from helpers. So that's going to be the name of the module this time. So from that module, what do I want? Well, I want to import in everything, and that's what that little star means. Now, once I import in everything, then everything that's inside that module will become globally available. Or in a slightly more technical manner, it will then be imported into the current namespace. What's the impact? Well, the impact is now when I want to access display, all I have to do is just simply say display. Let me clear the ink from the slide here and just highlight one more time here the little difference. What I want you to notice here, whoops, let me go back to the right little section here. There we go. Pen. Let me go ahead and highlight this little block right here and this little block right here. The only difference between them is whether or not we're using that helpers prefix. I want to stress this one more time. There's no logical impact on your code. There's no performance impact on your code. The only difference is literally just how we're going to call it. And a lot of times, it's just going to come down to a matter of personal preference. Sometimes it can make your code a little bit more readable, knowing where a particular function is coming from. Sometimes I just want everything right there, so I don't always have to type out that prefix. Again, the choice is yours. The last import statement that we have up here is where we're going to import in just a specific item from a module. This is very similar to what we saw up above. The only difference is now instead of grabbing everything by using that asterisk, we're just grabbing one item, and that we're doing by using that import and then just the one item. Are you going to let me turn you off? You're not. Okay. Yeah, that's all right. Down at the very bottom, you can see me calling the display. I know this slide is sort of showing the little stars there, so I don't know how exactly how readable it is, but it is actually the exact same thing that we're seeing right up here. So it actually winds up being the exact same code. Now, what's nice about just importing in individual items is it can help clean up your current namespace. That one of the little challenges that you'll run into if you bring in everything from a large module is it can start to clutter your IntelliSense so that every key that you start to type in gives you just a huge list of options. So if you know that you only need like 1 or 2 or 3 items from there, quite frequently it's best to just import those individual items. Now, for me personally, I typically trend towards that last bit of syntax there, where I'll just go in and grab the individual items that I need. But again, I want to stress, it's frequently a matter of personal preference. About the only time that it's actually going to matter is if you might have 2 items with the exact same name. Now, this is a module that we've created, but how about getting something that somebody else has created? Well, this is where a package comes into play. And a package is really just a published collection of modules. That's all there is to it. Now, the number one question that I get whenever I start talking about packages is, how do I know what's available? And the answer really is just through experience and through use. Now, if you actually want to start searching around, there is a full index available of packages called the Python Package Index. And you could go in and search inside of there. You could also go in and do an internet search. And honestly, if I'm about to do something that I think somebody else has done, I will always start by searching on the internet. And that's quite common because chances are, whatever it is that you're building, somebody else has already built it, or maybe they've built individual components. They just haven't put it together the same way that you're going to be putting it together. Reuse somebody else's code. The best code in the world is the code that's already written. So don't be afraid at all to go grab packages that are out there and import them into your application. Now, to install them, all that you need to do is to use pip. So pip is the command line installer that you're going to use. So in my case, I'm saying pip install and then Colorama. Colorama being a little package that will help you easily change the color of text when you do your print. Now, if you happen to have a whole list of packages that you want to be able to install, then what you can do is set them up inside of a little text file that's frequently called requirements.txt. Let me get back to the right slide here. There we go. And let me bring that back up. There we go. So my requirements.txt, what's inside of it? Well, it's actually pretty straightforward. It's simply a text file. It's just simply a list of all of the packages that you're going to be using. Now, if you want to pin down to specific versions and things like that, there is syntax, and I'll let you go check the docs for that. This is actually going to install the most up-to-date version. And sometimes that can be exactly what you're looking for. Sometimes that can potentially lead to problems, and you'll want to be aware of those possibilities. So if you're looking for, hey, how do I specify a particular version and so forth, you can go check the docs. You're going to find that quite frequently, though, all that you need is just the most recent version, and that's exactly what that syntax is going to get for you. Okay, this is a perfect time to take a real quick break. Then what I want to do when we come back is talk a little bit about environments, because pip is going to behave in a way, especially if you're familiar with Node, that you might not quite be expecting. And we'll take a look at that in the next video. Let's talk about the impact of installing packages. As we saw in that last slide before we cut over to this video, even with my ink still on it, and that's just fine, the way that we install a package is by saying pip install and then the name of the package. Now, what's going to wind up happening when we call this is it's going to install that package globally, which is a good thing, and sometimes it's a bad thing. That the impact of installing that globally means that it is going to be available for every application that you're going to be creating. But the downside is you might be running into some particular version issues and things like that. This is also relatively different than some other package managers such as NuGet or NPM that you might be familiar with, where in those cases what they're going to wind up doing is doing a local install of that package. So it would be available for just your application. Python does not behave that way. By default, Python is going to install all of those packages globally. So typically, as a best practice, what you want to do when you're setting up your application is to do a local install, and we do that inside of Python by utilizing a virtual environment. A virtual environment, put quite simply, is literally nothing but a folder that has all of the code that you're going to need to run the application that you're creating. So everything that I need is just going to be installed into that folder, and then I'm able to use it. Now, of course, I need to create that folder first, and we have a little utility called virtualenv that we can use to do exactly that. Now, we will need to install that, and the way that we do that is by saying pip install and then virtualenv. This one we want to do globally because we're always going to need that. And then the next step is to create that virtual environment. Now, like I said before, our virtual environment is nothing but a folder. That's all there is to it. So you'll notice in both cases here that I'm just going to specify the name of the folder that I want to create. You'll notice by convention, most people will just name it VENV, short for virtual environment. You can name it whatever you want. You can call it Wibble. You can call it, something else that might be a little bit more meaningful to you. It's completely up to you. Now, how you create that is going to vary slightly depending on the operating system that you're using. If you're using Windows, then it's going to be Python, which we've already seen, TIC-M, which stands for go grab a particular module, and then venv, which is that shortcut for virtual environment, and then specify the name of the folder again that you want to create. If you're using a bash shell, say inside of OS X or inside of Linux, then it's simply virtualenv and then the name of the folder. That's all that there is to it. And now, when it comes time to use that virtual environment, then what I need to do is activate it. And you'll notice the syntax to activate it here, and it's going to vary again depending on your operating system and also depending on your environment. That if you're using Windows, everything that you'll need will be inside of a subfolder called scripts. And then it's always going to be activate. It's just going to vary on the extension. That if you're using a command line, it's going to be a batch file. If you're using PowerShell, it's going to be a PS1 file. And if you're using a bash window, which is personally how I generally do things, then it's just simply activate, and then away you go from there. You will notice a slightly different syntax up at the very beginning here. You are going to notice that little dot, and then another space, a dot, and then the path to your folder. That dot is the location of your source code. You'll typically do this from the current directory. That is the syntax that you're going to need. Again, I've got placeholders for my folder names, as we've already discussed. Typically, that will be VENV, but it could be whatever folder name it is that you have identified. If you're using OS X or Linux, then it's the same as before. What's going to be slightly different is instead of scripts, it's going to be bin. That's where you'll find that activate, and then away you go from there. Now, to install into a virtual environment, after you've activated it, it's the exact same as doing a global install. So you'll notice, and I honestly just copied and pasted this slide and changed the title of it, it's simply pip install, and then whatever it is that you want. If you have a requirements text file, then it's pip install, and then that requirements text file. Okay, there was a lot that was going on there, and I think the best way to actually see all of this in action is to start working with it. So what I want to do is set up a little demo where we'll create a helpers py file, show how we can import that. Then we'll go ahead and create a virtual environment. We'll install Colorama into that virtual environment. And then we'll go ahead and use a little bit of Colorama in our demo. So that'll be the next video. Let's take a look at how we can use modules and install packages. So up here what I have is a little module that I'm going to use as my sample. So what you'll notice is I've got a little function that I'm calling display, takes two parameters, message, which is whatever we're going to print out, and then an is warning, which is just a flag. We're going to set that to false by default. And then what you'll notice is that if it is a warning, we'll just print out this is a warning. And if it's not, then we'll just not print that. In either case, we will print out the message. So I now want to use that from my demo here. And so what I can do is I can say import helpers. And now that I've done that, now I have that little display that we just saw available to me. Let me actually just put that kind of side by side so that way we can see that. Whoops, let me hit the right button. There we go. Cool. And so now let me go ahead and start using that. So what I could do is I could say helpers.display and then sample message. And so now if I run my little demos.py and make my IntelliSense go away, there we go, Python, and then my demos.py, and sure enough, we got our little sample message. And if I would have passed in true, puts it out onto the next line there. Let me just readjust. There we go. Cool. And rerun this. Now you'll notice that it prints out this is a warning and my sample message. So just like that, I can import in modules. That's all there is to it. Now, if I wanted to always make display available without having to use that little bit of helpers.syntax, then I could say from helpers, import, and then if I wanted everything, I could use the asterisk. Or if I just wanted that display, then I could just simply say import display. And now I can say display, sample message. And now if I rerun this, now what we're going to notice is that sample message showing up twice because I called display twice. And it's the exact same thing. The only difference is simply how we did the import. OK. See if I can't. Right there is the exact sweet spot without it putting in line breaks. Cool. So that's how I could go in and do that. But now let's take a look at how we could set up a virtual environment and install a package into there. So to set up my virtual environment, let me clear my screen here. The way that I do this is by saying Python ticm venv for virtual environment, and then I'm actually just going to say venv. Second time. Now, that second parameter there, this one right here, that is the name of the folder that I'm creating. So when you look at that syntax, you might be thinking, well, why am I typing venv twice? The second one is the name of the folder. The first is the command. You're going to notice most people will either just do venv for virtual environment, or sometimes they'll just do env for just environment. I really like that venv, so that's what I'm going to stick with. And I'll hit enter. And you'll notice that VS Code then pops up and says, hey, we noticed a new virtual environment has been created. Do you want to select it for the workspace folder? Now, what this is going to do is this is going to tell VS Code about all of the packages that I'm going to be using. It's going to know to look at that folder for all of those packages. What's the impact, you ask? Well, the impact is going to be that now VS Code can help me out. VS Code is now going to know everything that's there and will be able to show me the IntelliSense. You almost always want to click yes on this because I'm going to want that help from VS Code. So I'm going to click yes, and now it set that up inside of VS Code. But I still want to set that up inside of my local execution environment. And the way that I'll do that is by saying current directory, and then venv, scripts, and then activate.ps1. Now, the way that I know that I'm using my virtual environment is right here at the very beginning. You'll notice that it's showing me the name of the virtual environment. If you see that, you're now using that virtual environment. If you don't see that, you're not using the virtual environment. Now, that's for my code execution. How do I know if VS Code is using the right thing? Well, I can actually see that down here. Let me actually zoom in on that, hopefully make that a little bit easier to read. So down here on the lower left-hand corner, you'll notice right here, this is where it's telling me the environment that it's using. So I want to see my venv there. That's the name of my virtual environment. Now I know that VS Code is using it. And again, the impact here is that VS Code will now be able to help me out. So when we install Colorama, which we'll do in a moment here, it's now going to know that inside of VS Code, and I'll get my IntelliSense. So let me now do my installation. So we'll say pip install, and then Colorama. Now, by doing it that way, it's just going to install Colorama that one time, and that's it. Typically, the way that you'll want to do this is by using a requirements.txt file. So I'm just going to create a brand new file. Just going to call it requirements.txt. No magic. It's just a text file. That's it. It's in my current directory, just a text file, and I'm going to type out Colorama. Boom. And now I'll go ahead and say pip install, and then tick R for requirements file requirements.txt. And that will now do my installation. Now, it's going to install it into the virtual environment. How do I know that? Well, because I've activated it, and because one more time, I'm seeing that little V right there at the beginning. Now, I'm getting a little error message here telling me that pip needs to be upgraded. You'll probably get that like half the time that you run pip, I swear. And that's fine. You can go ahead and upgrade it. I'm not going to worry about it for right now. I've now got Colorama installed. Let's put Colorama to use then. And so I'm going to put that to use inside of my helpers.py. Because printing out this is a warning, that's kind of cheesy. Let's change colors here. So I'm going to say from Colorama, and I'm going to say import, and then we'll say init, which is what I'm going to need for Colorama, and I'm going to need my, my foreground colors, which are going to be like that. Cool. And why are you giving me green squigglies? Colorama. Ah, there we go. Cool. So now, let me go ahead and update this so that if it is a warning, we'll print it in red. And if it's not a warning, then we'll just print it in the normal color. So we'll go ahead and say else, and then we'll just print message. And you know what? We'll print the normal messages in green. The way that I do that is by saying for dot, I need to make sure that my casing is correct. There we go. There we go. So now we'll say for dot blue, and then our message. Otherwise, we'll go ahead and say for dot red, and then our message. Now, if you're curious as to how I know to do that, even though I got my casing wrong on 4, the way that I knew to do that is because I've worked with Colorama in the past. Again, if you're ever looking to do something, just search the interwebs. Honestly, that's how I discovered Colorama. I went, hey, I want to be able to display different colors when I print. I did a search, found Colorama, and here we are. That's exactly what I did. Okay, so now I've got my little red if it's a warning, blue if it's not. We're good. Let's go ahead and save that. And if we come back over here to our demos, what we'll notice is one time we said true, so we should see that in red. The other time we didn't do anything, we should see that in blue. Let's run it. So we'll say Python, and then our little demo, hit enter, and sure enough, our warning is in red, our non-warning is in blue. So what we saw in this demo and what we saw in this module is how we can work with our own modules and how we can work with external packages and how we can set up a virtual environment. Pretty much every application that you're ever going to be creating is going to have some level of requirement for installing packages. That if you're going to be using cognitive services, if you're going to be using Flask, if you're going to be using Django, you're going to be installing all of those various packages. And that's how we do it. Set up a virtual environment, set up a requirements text file, list the packages that you want, and then it's simply pip install from there. And that is how we work with packages and modules in Python.
Okay, we've learned a lot of different things we can do with our Python code. Now we're going to talk a bit about how to call an API. Now, APIs are very powerful, but let's take a little step back to sort of understand how they fit into things. When you've written a function, or you've created a library, which we've just talked about, and you want to share that functionality not just with yourself, but with other programmers, Generally, the way we do that is we create a web service. So we put our function onto a web server, just like you'd put a website onto a web server. And if you have the address of the web server, just like if you have the address of a website, you can visit it. If you have the address of a web service, which is just a function stored on a web server, then somebody else could potentially call your function from another computer anywhere else in the world. This is where things start to get pretty neat. So if you have the address, so I have a web server called Contoso, and I'm actually going to use a real-world example here for the example web service I want to call. There is a neat little, and let me bring it up here, a thing called the Computer Vision API. So this is a really neat little function. What it does is it's a library, a whole series of functions that allow you to do things with images. And so you can pass in an image and it'll tell you what's inside the image. So it does some artificial intelligence, data science, analyzing the image and returning you its contents. Or you can pass it an image containing some text and it'll tell you what text is actually read from the image and so on. So if I wanted to call this Computer Vision API, and I want to call Analyze Image, so I want to pass in a picture, have it pass me back, tell me what's in that image, then I need to know, first of all, its address. So I need to have documentation from the person who created this web service to figure out how to call it. So in this case, it's a well-documented service, so I can go to the documentation on the site, and I can see the different addresses it might be using, and I can see the name of the function. So over here, when we say call, my code has to call it, basically I need to know that server name and the name of the method I'm calling. And these are examples of other services in the Computer Vision API that I might have chosen to call instead. So first of all, I need the address. So of course, if I'm calling a function, as we saw in the module on functions, when you call a function, you probably have to pass in parameters. Just because a function is stored on a web server doesn't change that fact. So I have to know the function name, and I have to know the parameters of the function I'm calling when I call a web service or an API. So again, if we return to the documentation, we can see all the function names listed here on the left-hand side for this particular documentation: analyze image, batch read file, detect objects, OCR, and so on. And if we scroll down, we can actually see the parameters. So you can see here are the parameters that this function expects when it's called. These are the parameters for analyze. So it expects me to pass in visual features. It tells me that's going to be a string, so I know the data type. And it even tells me what sort of information that is and what the valid values are I can pass in. And then it says there's a parameter called details and a parameter called language. So language, for example, if I specify English, that means when I say, please analyze the image, return the results in English, or return them in Spanish or Japanese. So that allows me to say if it sees a bear, it can return the word bear in English, Japanese, Spanish, and so on. So now I know my name and the parameters by looking up the documentation of the web service I'm calling. Now, here's the other interesting thing. If I just put my function up on a web server and put out the address, does that mean anybody in the world can just call it anytime they want? I probably want to have some way of controlling permissions of using it, because if nothing else, I'm probably paying for an internet provider, and the traffic coming into my web service costs me money. So I might actually charge people to call my program. Or I might not. I might make it available for free. Depends on why I'm making it available. One of the ways we do that is by using keys. So one of the things we'll often see on websites and when we play with APIs and web services is you might say, what's your key? So generally speaking, there'll be a website you have to go to, or when you buy a license for your software, you're provided with a key. And that key is unique to you and gives you permission to call my web service. So when you call my web service and you pass me that key, I go, oh, I know that key. That's Susan's key. I remember she signed up for it, or she's paid for it, or she gave me the information I wanted to know so I could trust her to call my function. And once I know you have that key, then I'm like, okay, now I will let you call that function. So usually there's something you have to do, create an account, create a service or something to get that key. And that key is basically your permission to call the function that's stored on this web server. Now, there's also a standard for the way we send messages across the web. It's called Hypertext Transfer Protocol. That's when you see that HTTP everywhere. You see it on websites. You don't have to type http://www. But you'll see it all the time at the top of your browser. So basically, this is a protocol we use for talking across the internet. And there's two standard protocols we use for sending messages under HTTP. One's called GET and one's called POST. And if you actually go back again to our computer vision API, you can actually see here on the left, when I look at the documentation, it tells me, hey Susan, if you want to call analyze image, you have to do a POST. If you want to call list domain specific models, you'll have to call GET. If you want to call OCR, that's going to be a POST. So the documentation will tell you which one you need to use. What's the difference between the two? It's subtle. The difference is with a GET command, you pass values to the function using something called a query string. So it's all part of that big long address. And if there's any special characters like slashes and stuff, you're going to need to use escape characters because it doesn't like special characters. So there's extra things you have to do to deal with those characters. It also has a limited amount of data that you can pass in because there's restrictions on how long that address can be when you put the query string on top of it. So that whole thing will appear in like the address bar of your browser. Now a POST, you can pass in values with that query string, but you can also pass in a message body, and that's much better. Well, it can simplify things. You don't have to worry about if there's special characters in the body part, and also you can pass in more data. So that's what we typically use if we have to pass in a file. We'll usually use POST because when we put POST, we can put the file we want to pass in, the image we want to analyze can be put inside that body. So that's typically when we use a POST. And if we take a look here, the analyze image method, you'll notice it says I'm going to use a POST, which makes sense because I'm going to have to pass in the image, but I want this function to analyze for me and tell me what's in the image. Now, one of the things that's really useful in Python is something called the request library. So you just learned about libraries. Libraries are great, do all kinds of things to make our lives easier. And one of the libraries you want to use when you play with HTTP is called requests. Because what it does is it basically simplifies making a POST or a GET call. So you just import the request library. You'll have to do a pip install first, just as Christopher was talking about. And then you can call request.post. So I say, hey, I want to do a POST call because I know that's what I need to do for analyze image. And if you look up the documentation on request.post, it will tell you you need to pass in an address. So the address is, what server is this on? What's the name of the function you're calling? That was on http://contoso/analyze. How do I know that? The documentation on the web service. See, these are the possible servers it could be on. Here's the name of the function. Then I have to pass in the HTTP headers. Scary stuff. No, don't panic. Go look at the documentation. If you take a look at the documentation for the analyze image, so here's documentation on analyze image, tells you doing a POST, and it will also tell me, by the way, here's the request headers. So it tells me when you pass it in, these are the values for the HTTP headers. You need to specify in the content type and the subscription key. That's where I pass in that key that gives me the permission to call the API. Then the function parameters. The function parameters, that was the parameters. Look at the documentation. It told me here's the parameters that it expects and the acceptable values for the parameters. The documentation will vary depending on how good and how organized the people are who create the API, but good documentation helps a lot. And then the message body. That is the image that I want to pass in. And how do I know that? Again, I know it because I looked here and in the documentation it said, hey, when you pass it in, you pass in a file, and it even tells me what file formats it'll accept. You can pass me a JPEG, a PNG file, GIF, can't be larger than 4 megabytes, so it even gives me some great parameters to help me increase the chance of success when I call it. So that's the image I want to pass in. So learning how to call APIs, or really learning how to go look up the documentation on the APIs and mapping that back to your calls, is going to unlock a whole new world for you. This is how you call neat services that already do neat stuff with data science to read text, analyze images, connect to third-party services. You're going to see it all over the place. The documentation is key. But let's go and now take a look in actual code and call an API and see what it works like. All right, let's try and actually create some code that calls an API that someone else has written. And this is the sort of thing we frequently end up doing in our code. Maybe it's somebody in our company has written and stored as a web service, or maybe we want to call a web service that someone at a different company has created for us, but does some neat functionality that we'd like to leverage. So in this case, I want to call the analyze image, which is part of a cognitive service in Azure. So if I bring up the documentation, and remember, it's often going to come back to go look for the documentation, do a search. It tells you how to first create the service, because remember, I'm going to need that key so that I can call it. And the way you do that with this particular one is you have to create the service first. And in this case, that does mean I need an Azure account. So there are tutorials that tell you how to go create your account for free and create the Cognitive Services resource. So I already have my Azure account, and I've already logged in at portal.azure.com. So I've gone to the Azure page, and then I say, I find the easiest way if I know what I'm creating. And in this case, I want to create, because I know that Analyze Image is part of the Computer Vision API. So I've already logged into the Azure portal at portal.azure.com, and because I know from the documentation that I need to create a Computer Vision API, I can just go to the portal, and I find the easiest thing to do to actually go and do a search for Computer Vision, and you'll actually see it pop up Computer Vision rather than digging my way through all the submenus to find the one I want. And I click on Computer Vision, and it says, oh, you must want to create a Computer Vision API. Yes, I do. Thank you. That's how I'll get the key and the address I need to call it. And let's give it a name, and let's just call this playing Python image analyzer. So I'm writing this I'm going to write Python code that's going to pass an image, and it's going to analyze the image for me. You do have to have a Microsoft subscription. I'm just going to pick my Visual Studio subscription here. Now, the address is going to depend on where you have this service created. So the way Azure works in the cloud is when you create a service, you actually get to pick which data center it's stored on. So you want to pick one that's fairly physically close to where you are at the moment. I live up in Canada, so I might pick Eastern US, or there are some in Canada as well. And then the pricing tier, you'll notice there is a free tier. F, in this case, is the free version. And for what I'm doing, the free tier is going to be perfectly fine. A lot of times when you just want to try something, you can try it for free, and you only have to go to a paid version when you're doing something in production. And then the resource group. A resource group is kind of like a file folder which keeps your stuff together. So when you're creating multiple resources in the cloud, multiple services, you can put them in one resource group, and that way you know where they're all located to delete them or modify them later. So I actually, let's just create a new resource group called Resource Group Python Fun. So I'm just going to create a new one. And then if I do anything else later, I'll just keep it in that same resource group. So think of it kind of like a project folder. So I can create that, and then what's going to happen is it's going to create that subscription, but for the sake of simplicity, I have already got one that's created. Once it's done, I can actually go to my all my resources, and I will actually say, whoops, no, I don't want to leave that, thank you very much. It is validating. Oh, it's still checking to make sure it's good. Okay, there we go. So it's going off and creating that service for me. Now, once it's created the service, I want to go to the overview page. That's the most important page for me to be able to call it, because what will happen is when I go to the resource and I go to overview, it'll tell me the address of where that service is located and the key I need to call it. Remember, those were two of the things I needed to call a service. So here, the endpoint, that's my address. So in this case, I picked East US, so it's eastus.api. That's how it knows which of the various addresses. Remember all the different addresses we saw here? The one that you use depends on where you create the service. And here we have that manage keys. So if I click on show access keys, it will actually give me the keys here, and I'll be able to copy and paste them. There we go. It's two different keys I can choose from. Doesn't matter what you use. And I can just copy that. And when my code, when it asks me the key, that's the key I'll put into my code. All right. So now I have a web service ready to call. Now I need to go to my Python code and actually call it, see something happen. So what I've done here is I've got some code, and I'm just going to walk you through it. And this is in the GitHub repository, so you'll be able to download a copy of this code, play with it yourself, create your own service, and explore it. This is one you really want to spend some time playing with. You'll see some familiar commands. I'm importing that request library. That makes it easier for me to make my HTTP calls from Python. I'm importing another one called JSON. I'm going to talk more about JSON in the next module, but the data that comes back from the service I called is in format called JSON. So I'll talk more about that next module, but I just need that for holding the results come back. I've already copied and pasted my subscription key over. That I'm going to need to have so that Azure knows I have permission to call this analyze image. I have my address. This is from a service I created earlier, so the address is different than the one we just showed. But that's the address of the service I created. And the address in this case, you also have to specify that it's analyze, because this is the address of the computer vision API, and I need to specify that I want to call the analyze function of the computer vision API. How do I know that? Guess what? You know a way I know that? It's because I looked at the documentation. So you can see here that when you call it, you'll see here it says request URL. You'll see it says analyze. So here's the address. The only thing that changes is the server name, and analyze is the name of the method. So always in the documentation, I find this stuff out. Let's go back to our code. Keep going through and see what else we can figure out. So we have the address. So we know where we're calling. We have the function name. Now we have the parameters we want to pass into the function, because anytime you call a function, you have to pass in the right parameters. So I need to pass in, what are the parameters? Back to the documentation. Visual features, a string indicating what visual feature types to return. Multiple values should be separated by commas. Valid values include. So this is basically saying when I ask this function to analyze an image, I have to tell it what information I want back. Do I want to know the colors that are in the image, a description of the image, if there's faces in the image, what objects are in images, or tags that are in the image? So I've chosen to say, give me back a description and the color. So those might be the ones. You could add more, take away less, and change those. And I've also decided that I would like to have it back in English. So I would like, if it says there's a bear, I want the word bear in English. So I've specified my parameters. Now, in this case, I have to pass in that actual image that I want to analyze. So I actually have a subfolder that I've created on my computer, and I'll have that in the GitHub for you as well. And it's called a polar bear. So it's just a picture of a polar bear. Actually, if I open it up, I can put that into an image object. So I'm doing some Python here. This is a little bit new. If you look up, this is the open command. It allows you to open a file and put it into an image object. So I can pass that image to the function. Now I also have to pass in those HTTP headers. That was something else I had to do. And in this case, what do I pass in? Check the documentation. What do I need for the headers? There we go. I need the content type. And the content types can either be JSON or octet stream or multi-part form data. These are the content types I can choose from. And basically that just indicates, am I passing the image as here's the address of the image on the web, or no, here's the actual image. And if you're passing the actual image, that's octet stream. So you'll notice my content type is set to octet stream. The key is the key that I entered earlier. I've just put it there. And by the way, right now I've just put the subscription key in the code. Not a best practice. I'm doing it so you can follow my code and play with it. But if you had that key, if I kept this key and you knew it, you could call it and call the web service and I'd be the one paying for it. Not the way I want things to work. You basically using, it's like me giving you my house key. You can come to my house and open the door. If I give you my API key, you can go to this API and pretend you're me. So I don't want to do that. I want to protect it. Christopher's going to show you the right way to store your API keys in an upcoming module. So make sure you watch that one. So now I have all the information I needed. I have the address. I have the headers. I have the parameters. Now I'm ready to call this web service out there somewhere, well, on the data center. So I call request.post. And I pass it the address. I pass it the headers. I pass it the parameters. And I pass it the data that I've just set up. I've got an extra line of code here that I find is really useful. What this raise for status does is it basically says, if when I call that web service something weird happens and I get an error, please raise an exception so I can handle it just like any other Python error. Because that allows me to do my try finallys and things like that in my code, which you learned in the error handling. So that allows it to raise the errors like an exception in my code. So I can handle it the normal way. And all I'm going to do for now is I'm just going to display the results on the screen. Don't worry too much about this code. We're going to talk more about JSON shortly. But if I'm lucky, then when I go here now, all that code, but what's amazing is when I'm done, call api.py, and hopefully it's now actually going off to a server somewhere out there, checking my key, making sure I have permission, passing in the image, and coming back and saying, hey, here's a bunch of information about that image. Wow. All right, we've successfully called a web service. How to understand that data that came back? We'll cover that in the module on JSON. Okay, so when we looked at calling an API, we finished by getting some data back in this big dump of data, and it was a little confusing. That data we got back was JSON. So what I want to do now is show you how to navigate that JSON structure, because it's a little scary at first glance. JSON is a standard data format that's used to pass data back and forth, but it can be very intimidating at first glance. What you see here is the actual JSON that was returned by my API call when I passed in a picture of a polar bear and asked the Analyze Image service to tell me what was in the image. This is the data that came back. But it said it looks a little scary when you just look at it all displayed that way. How would I read this using code? Well, the first thing you want to do is there's a whole bunch of websites and things out there called JSON linters, like lint you find in a dryer. And what that will do for you is if you take some JSON and you put it into a linter, it'll format it nicely so that you as a person have an easier time reading it. So that's going to make your life easier. It's the first thing I do when I get a chunk of JSON is put it go to a website that does linting, copy and paste the JSON there, and then I look at it this way, and I look at it and I say, oh, now I kind of see what's coming back. What I'm getting back is, so I had a variable called results, which held the code that was passed back, and I can see it gave me back a color that was in the image, and it told me the dominant color in the foreground and the background and the accent colors and whether or not it was a black and white image. For some reason it gives you that tag twice, not sure why. And then it gave me a description telling me the tags of what it saw inside the image. It's a bear, polar bear, it's an animal, a mammal, outdoor, it's all water, white, large, and so on. It tells me a caption that it generated. This is a large white polar bear walking in the water, and a request ID, which just uniquely identifies my call to that API. So this is what actually was passed back when I called the Analyze Image service and I passed it my image. This is what it found inside the image, based on the parameters and so on I passed in. Now, how do I use this in code? How do I actually write code that reads through this messy looking JSON, even though it is very structured? Basically, what you'll notice is there's a pattern to how the JSON data looks. It's basically a series of key pairs. So you have a key, request ID, and a value, the value of the actual request ID itself. Sometimes the pattern is you have a key, and for that key there's a series of subkeys and subvalues. So for color, you'll notice there was, for each color, it said there's the dominant color foreground, dominant color background, dominant colors, and for each of those is a value. So this is an example where I have a series of subkeys and subvalues for the key of color. Or for a particular key, you might have a list of values, like we did with the tags. So tags is the key, and for the tags, there's multiple values that are specified. So it saw it was a bear, it knew it was an animal, it knew the picture was outdoors, it saw water, it knew it was white. So all of those are tags. So you'll see the square brackets indicate it's a list of values. Those are all different tags. So it's a list of values that go with the tags key. So when we want to read this with our code, we have to know which of these structures we're dealing with. So there's different methods we use to basically read through the JSON, and we have to read it slightly differently depending on whether it's a key value, key and subkeys, or key in a list of values. Let's say you want to retrieve the value from just a straight key value. This is the easiest one to do. What we do is we're going to import the JSON library, and then what we can do is with our results, so I'm assuming when I called the code, and I called the web service, the results were passed back to a variable called results. So results is the name of the variable that contains that big JSON string. So all I have to do is say, give me the value of the request ID. And basically it'll return to me that value for the key. So you pass it the key, it will return to you the value. Now what if I need to retrieve a value that's in one of these key subkeys? So I have the color key, and for the color key, I want to know the dominant color in the background. Like, what's the primary color of this image? In this case, white. So what I have to do, and you can think of it kind of like a series of file folders, I have to say, well, go into the color key. And then in the color key, go down to the dominant color background. So think of this as like folder and subfolder. And then say go to color, dominant color background. That's the key name I want. And it will return the value of white. So it returns the value of the key I specified. So I said, think of this like a folder and a subfolder. Might be an easy way to think of how you drill down and specify the key you want when there's subkeys. Now, if you have a value in a list, so in my JSON when it came back for description, for tags, there was a whole list of possible values, or actual values returned for the tags. So what if I want the first value in the list? Well, if you think back to that module we did on lists, we had index positions to indicate first index 0 is the first one in the list, 1 is the second in the list, and so on. So what I can do is I can say, use that description, say go to description tags. So go to the description key, under description key, go to the tags key, and then just give the index number of the particular tag you want back, 0. Of course, most of the time, and that will return bare, but most of the time you probably just want all of the tags that came back. So to do that, you would just use a loop. So I can simply say for each item in results, description tags. So if you go to description tags, for each item in this list, print it on the screen. And that allows me to go through literally and display every single tag that was returned in the JSON. In addition to needing to read JSON, there's going to be times when you might need to create JSON too. You might be required to create JSON to pass to a web service. So if that's the case, how do I actually create JSON with my code? Usually we use dictionaries. So dictionaries have that same concept of key-value pairs. So since JSON has key-value pairs, the Python dictionary is like the perfect mapping to it. So the good news is you can use the JSON library and you can actually use the JSON dumps method, give it a dictionary, and it'll create JSON from the dictionary. But exactly how you create the dictionary depends on which of those 3 structures you want to create. If you just want to create key-value pairs, like I might create a dictionary object here for a person. We saw this when Christopher covered dictionaries and collections. I have a first name of Christopher, a last name of Harrison, and that's 2 key-value pairs I'm putting in the dictionary. And then you can add additional key pairs if you need to. I add another key called Seattle with the value of a key of city is the value of Seattle. And then I use the JSON library to say, hey, use json.dumps. This is one of the features of a library. Pass it the dictionary, and that will return a JSON object. And then if I print that out, you can see it shows me the 3 key-value pairs. So if all you need is key value, key value, key value, just create a dictionary, use json.dumps to create that into a JSON object. What if I need that key subkey? Okay, if you need those subkeys and subvalues, it's a little more complicated, but what you're really doing is creating a dictionary in a dictionary, if that makes sense. You'll have to play with this to practice it and get used to it. So I have that person dictionary, which contains Christopher's first name is Christopher, last name is Harrison, just like I did before. But imagine if I had a JSON object that showed us our staff directory. And each staff position, there's a person associated with it. And for that person, we know their first name, their last name, what city they live in, and so on. So I might have a staff dictionary, which has a key of program manager. And the program manager is a particular person. And for that person, there is first name, last name, city, and so on. So what I do in this case is I create this staff dictionary, and then I create the key program manager for staff dictionary. But instead of just saying it equals Christopher, I say it equals the dictionary object, which contains Christopher. And then you actually get that nested set of subkeys when you create a JSON object from that dictionary nested in a dictionary. If you need to create a JSON object that contains that list of values, then instead of putting a dictionary in the dictionary, you actually put a list in your dictionary. So again, in that module on collections, we learned how to create lists. So what I can do is create my person dictionary. First name is first key is equal to the value Christopher. The last key is equal to the value of Harrison. And then I create a list of all the programming languages he knows. And I say he knows C#, Python, and JavaScript. So this is just a Python list object. Then I create a new key in my person dictionary called languages and set it to the entire list. Then I take that person dictionary, change it into JSON, and now I have that list embedded in my JSON. So those are the three basic scenarios you'll be playing with if you're trying to create JSON with your Python code. It takes a while to get used to this. Chances are you won't get the code right on the first time. The first time you have to read JSON or write JSON. So a couple of tips to help you out. One, use print statements all over the place to help you debug. When you do a JSON.dumps to create the JSON object, print that JSON object out to make sure it looks the way you expected. When you're trying to read JSON, you may want to do print statements to show the values you read and gradually work it out until you figure out the right syntax to get the right sub key and the right list item. So play around with print statements. They will really help you master your JSON skills. Use a JSON linting tool. Just go on the web, search for JSON linter, and then you copy and paste your JSON into it, and it'll give you that nice formatted view, but it's a lot easier for a human to read, so you can see the pattern of keys and subkeys or keys and list values and see which ones go together. And finally, I actually find it useful the first time I call an API that returns JSON, I actually usually copy and paste that JSON lint it, and then I keep it in something like a Word document on the side to refer to as a reference as I'm trying to figure out how to navigate the JSON and read what I need. So that's the theory. Let's try it out in practice in some code. Okay, so when we finished that module about APIs, we'd successfully called the Analyze API, and we passed it a picture of a polar bear, and it had returned us some JSON. So this is the exact code that we have been looking at. So I've just taken that same code here, and when we run this code, scroll down through here, it had returned a pile of JSON, and it looks sort of like this if I lint it. This is sort of the data we had returned back. So what I want to do now is I want to add a little bit of code that returns just one of the values. Let's start with the basic key value pair. So here's a very simple key with a value that was returned in my JSON. So I want to add a line of code that says return to me the value of request ID. So what I've done in my code is I've gone, this is exactly the same code we had earlier, scroll down, and before I just done that JSON.dumps command. I did import JSON, by the way, at the very beginning of this. And I'm using the JSON dumps method to just dump the JSON out on the screen. But if all I want is one particular key value, I can just say, let's get the request ID. So by doing a print results, because remember results is the name of the variable that contains the results that were passed back by my API call. So up here I said response equals request.post, and then I said results equals my JSON that was passed back. So here's my call to the API. Whoops, sorry, a little too fast there. So here is my call to the API where I called request.post, covered in the API module. Those results are put into response. I call response.json to take the JSON passed back and put it into a variable. And then I can ask for a particular key. So I say, go give me the value of request ID. I've also got the raw JSON displayed as well because I find that helps me when I'm doing my debugging. Oops, I'm on the wrong slide there. Let's go here. So now let's run it. Read key pair. And it should show me the entire JSON, and then it should show me just the value of that request ID. So here you can see the whole JSON string that I had copied and pasted into the linter to try and understand it. And then you can see the request ID value was this long string here, and you will actually see, here it is, request ID is that value. So I'm able to extract just one key value pair from the output. Now, what if I want to read subkeys? The other thing we had here was these colors, and what if for a particular color I want to know the subkey of the dominant color background or foreground? So to do that, same thing, except at the bottom, what I have to do is I have to specify that go into the color, and within the color, return the dominant color background. So the only thing I've changed here is I've changed this one line of code to say go to color, dominant color background. So if I run that, and this is in a different file, so I'm going to call read subkey.py. By the way, all these files are in the GitHub repository, so you'll be able to download this, play with this, poke around with it yourself. And again, you'll see the full JSON displayed, and then you'll see that one specific color. So you can see here we had the dominant color background in the JSON was white, and you can see here that I see my code successfully retrieved that one value from the JSON. If you have a list of values, we were talking earlier about how for tags, for example, to see what was in the image, it gave me a list of all the different tags of things it found in the image. What if I want that full list back? Well, then what I need to do is after I've called it, and I've got my JSON in that results variable, I have two options. I can write a for loop that says for each item in the results description tags, print out that item. That will loop through and show me all the tags. Or you could say retrieve the first tag or the second tag or the third tag and so on. So I'll just retrieve that first tag. So now if I run that, list.py, and you can see what happens here. I'll just move this up so you can see all the output a little bit better. You can see here's the raw JSON that was printed, and you can see all the tags, and you can see this is how it appeared in the original JSON. And you can also see the first tag that was read, which was bear, which is indeed the first tag that was returned. So those are some examples. You really have to play with it. Call an API, try this out, explore, try retrieving different values to practice how to navigate that JSON. It really does come with practice. There's also a lot of great tutorials online that give you a lot more detail on JSON. Now, what if I need to create JSON from my code? Well, I said dictionaries have key value pairs, so we can create a dictionary in Python and then convert that into a JSON. So if I create a dictionary object, which we covered in the collections module, and I say I have a key value of first with the value of Christopher, key value of last with the value of Harrison. I add another key pair if I need to. So I might be reading values from a file and adding the key values dynamically as my code is running. And once I've added all the necessary values to my dictionary, I call that same JSON.dumps function. I pass it a dictionary, and it will then create a JSON object for me. So if I go here and we run this, you will see that JSON object that got created from my dictionary. So that is create JSON from dictionary.python. And you can see there is the actual output. You can see I have successfully created valid JSON syntax. If you need that, that's just for straight key value pairs. If you have subkeys with subvalues, you have to put a dictionary inside a dictionary. So that was the one where I sort of said, hey, let's create a staff dictionary and assign a person to a staff position of program manager. So what I've done here is I have that same person dictionary, then I create a staff dictionary, and for the program manager key, I assign the entire person dictionary. So now I have a dictionary in a dictionary, and when I run this code and I convert that to JSON using the same function, the dictionary becomes converted into keys and subkeys. So if I run that, create JSON with nested dictionary, there you go. You can see I have that those subkeys here. So it's that key of program manager, and for program manager, I have a series of subkeys. Finally, I might need to put a list, kind of like those tags, into JSON. I might need to create one with that format. That's done by creating a list item. So I create a dictionary object, same as I did before, and then what I'm doing is I'm creating a list object, and I'm assigning that list as a value to one of my keys in the dictionary. So when I add the languages key to my person dictionary, I give it the entire list. And then I convert that to a JSON object. And when I print this one out, you can see that it successfully created in my dictionary the key of languages, and the value for languages is an entire list. This can be really confusing. You're going to have to practice it. I really recommend go to the GitHub, download this code, play with it, practice creating different structures, practice reading different values from inside the JSON. It will come with practice. But now you've got enough to read the outputs of those APIs, so really you're starting to open up the world. But Christopher's got a few more tips for you to help you out when you're working with APIs.
In a prior video, one of the things that Susan showed off was how to call an external API. Now, whenever you call an external API, you're going to need some form of a key or password or otherwise. And this allows you to prove to that external service that you're calling that you are who you say you are, And if there's like some form of billing or otherwise, that the service then knows who to charge. And that's fine and dandy. And when Susan went in and she did her little demo, she put the key that she was going to need inside of the Python source code. And for a simple little demo, for a simple little proof of concept, for a file that's never going to be published to anywhere, that's fine. But for anything at all, which is honestly going to be the vast majority of code that you're going to be working with, that's potentially going to be shared with somebody else, that's never a good practice. That sharing a password or putting a password somewhere inside of a clear text file that's going to be publicly available is a bad idea for security purposes. That's my little tip from me to you for today. Now you might be thinking, well, duh, Christopher, everybody knows this. And if you know this, then that's fantastic. That's wonderful. But if you head out onto the web and you start searching around, you'll actually find all sorts of stories of keys, of usernames and passwords that have been shared out in source code files out on GitHub publicly for the world to see. That's bad. So as a result, whenever we're working with any type of sensitive data, we need to be careful about that data. We need to ensure that that data is going to be properly taken care of, and in particular, that it's never going to be stored somewhere that's publicly accessible in clear text. So, how do we do this? Well, we do this through the use of environmental variables. Now, in my lead up to this, I really focused in on just how to work with our secure values. But environmental variables are not just about things like passwords and keys. They're actually also there for anything that might need to change or otherwise from outside of your application. So for example, when it comes time to connect to a database, I'm going to need a connection string for that database. What happens if that database moves? What happens if that database is renamed? I'm going to want to be able to change that value without going back into the application to update that. Or what happens if I need to be able to read something from the operating system? Maybe I need to figure out the current directory. Maybe I need to figure out what operating system we're running on. Who knows? Well, I don't want to hard code that in. I want to be able to read that from somewhere external to my application. And that's where environmental variables come into play. Now, your operating system has a whole host of environmental variables. They might be broken down into, say, system level, so it's for the operating system, and user level, so ones that are specific to you. Might be other breakdowns from there. Maybe you've created a couple that are specific to an application. Who knows? But regardless, the way that you're going to read them is going to be the same. Now, what we'll do is we'll import the OS library, and then off of that OS library, we're going to call a little helper function called getEnv, and then pass in the name of the system variable or environmental variable that we want. In my case, I'm going to go grab the OS version, and when I print this, what this is going to do is this is going to print out Windows NT. Now, this will read any system or user environmental variable that has been set. But as we mentioned previously, there might be other things that we want to be able to set that are external to our application. Again, those database connection strings. Again, those keys, those passwords, those sensitive things that we want to be able to protect. So how do we then manage those? Well, it would technically be possible for you to go in and set those system variables, or maybe set it from the command line or otherwise. For me personally, the way that I like to manage this is through .env. .env is a package that has a version available for, I think, basically every major programming environment. that if you're doing Node, if you're doing C#, if you're doing fill in the blank, that there's going to be a version of .env available to you. Now, what's great about .env is it gives you the opportunity to set and store those environmental variables inside of a text file. So this way you never hard code anything. This way you're not checking in those sensitive values into your source control. That what you do after you grab that .env package, and we've already seen how to do packages, you create a .env file. And this .env file is literally nothing but key value pairs. You set your key, and then you set your value. And then what you'll do inside of your code is you'll just simply import in that load.env function from .env. You'll then call that before you do anything, and then you go grab your environmental variables the same way that you would normally. Now, the one thing that I want to highlight here is the fact that .env is really smart. What it's going to do is it's going to look to see, hey, was this set already externally? And if it was, then it will read it from there. If it wasn't, then it will go look at your text file. Now, the reason that that's important is because let's say that I'm going to take my application, maybe it's a web app, and I'm going to deploy this out to another computer, to a server, and have it run up there. And on that server, I'm going to set those environmental variables. I'm going to go in and specify what my keys are, what my database connection string is, etc. And I'm not going to do that through text files. I'm going to do that through the settings for that server. I leave in the exact same .env code. So everything that you're seeing down below, everything that you're seeing inside of here still remains in my deployed code. I'm not going to deploy .env. That .env is for local purposes only. This is for my local dev. When I go to publish it out, then I'm going to properly set my environmental variables. Don't worry, I'll show you how to do that. But my code remains the same. And that's the great advantage to .env, is that I can set everything up that I'm going to need for dev purposes, and then when I'm ready to publish my code does not change. And again, as I mentioned before, .env, there's a version of that for every programming language that you might be interested in using. So to review all of this, some final notes. Don't hard code sensitive information ever. Simplest way to handle this, which will work for most applications that you're going to be working on, is to use .env. Now, if you are going to use .env and you're using, say, Git to manage your source code, make sure that you add that .env file to your git ignore. Make sure that you do that so you don't accidentally publish this out. Now, if this is truly sensitive data, where if this came out, it would be completely catastrophic to our application or to our business, then you may want to consider something that's going to be more robust than .env. There is a solution available in Azure that's called Azure Key Vault that you can go ahead and check out, and that's fine. You can go ahead and investigate that. But like I said, for a lot of the things that you're going to be working on, .env is kind of a good enough solution, and it's relatively straightforward to set up. In fact, let's go in and take a look at that in the next module. Let's take a look at how we could use .env as a way to manage our environmental variables. As a real quick side note, I'm actually going to close off this video taking a look at how we could add in environmental variables into a website that we may have deployed out to Azure as well, so you can see how you're going to do that on the other side after you've done your deployment. But first up, .env. I've already set up my environment. See what I did there? See, environment Anyway, so I've already set up my environment. I've got my virtual environment already created. I've told my Python little PowerShell down below to go ahead and use that. So we're all set. And I've already set up my requirements.txt file. Now for that .env package, the name of it is actually python-.env. So I've got that inside of my requirements text, and I'm going to go ahead and install that like we've already seen using pip install r and then our requirements.txt, and that will do the installation. Now while that's doing its thing in the background, I'm going to go ahead and create a brand new file that I'm going to call .env. And .env is simply going to be a series of key value pairs that we're going to use for our environmental variables. So it might be something like this. Maybe it's password or whatever it is that you might have equals don't share this value, or whatever it is that you might have. Maybe I've got, instead of that, let me put it that way just to make sure that we don't mess anything up. So there's our sample little password. Okay. Now, it's also worth highlighting for those of you that are using Git, that if you've, when you set up your git ignore, make sure that you add .env into there, so that way you're not accidentally publishing out your .env file. Don't do that. You're basically back now to hard coding in values and sharing that out. Again, not a good practice, not a good idea. Okay. So let me close that out, and I've got my .env. I'll go ahead and just leave that there, and let me go into my app.py. So let's start adding in the appropriate code for .env. So I'm going to say from .env import and our load.env. Now again, we need to do our load.env just like that. If you happen to put your .env file somewhere else, you would specify that as a parameter. I just always leave it as .env inside my root. It's the easiest thing for me to do. Now, let me go ahead and say import OS to bring that in. And now I can say password equals, and we'll say os.get env, and then password, just like that. And then we'll go ahead and print out our little password. By the way, the reason I'm seeing green squigglies here is because I've got a spell checker installed. If you're a developer, or at least if you're anything like me anyway, you have a lot of typos. So that's why I'm getting green squigglies. If I went ahead and just added that into my dictionary here, we'll make that go away. There we go. So now no more green squigglies. So there's my code. We'll go ahead and print out our password. Let me save that, and let's go ahead and run that. This is under my app.py, hit enter, and voila, there is my little don't share this value. So that's how you can use .env as a nice little way to put your secure information, put your connection strings, all that stuff off to the side, and be able to load that in, not hard code anything, and more importantly, not share any of that publicly. Now let's take a look at how we're going to do this, say inside of a web app that we've deployed into Azure. So I've loaded up the Azure portal. I'm going to go under App Services here. And then right here, I've got a little web app that I've created before, Geek Trainer Testing. I'm going to open that up. And then what I'm going to do is scroll down to Configuration. That's the option that I want right there. Under my configuration, what you're going to notice over on the right-hand side is my application settings. My application settings are simply key value pairs, and you'll notice that it's already hiding those values. So that way you can see what the names are, but you're not accidentally going to display any secure values here. So now I could go in and add in my application setting. Sample is what I'm going to call this. This is a sample value. And then click Update. And just like that, I've now added that in as my app settings for my web app. Now, how would I bring that in? Funny you should ask. It's the exact same code that we've already seen. the way that I read those application settings is by simply saying os.getEnv, specify the name, and away we go. It's also, again, worth reiterating the fact that when you're using .env, you can leave this code right here already there. Everything is still going to work just fine. So I don't need one code base for when I'm doing my local testing and a different code base for when I deploy this out. One code base, publish it out, away you go. That's it. Again, just make sure that you don't publish out that .env file. And that's how we can use .env to help manage those keys, those settings, and where we can put them inside of a web app, inside of app services. Let's talk a little bit about decorators. Now, the goal of this series is to help get you up to speed, help teach you enough Python so that way you can go off and start learning how to use things like Cog services, how to create web applications, etc. Basically, our hope is that when you finish all of these videos, that you'll have enough information that you could start reading through some docs, reading through some quick starts, and go, oh, okay, I understand what's going on here. So as part of that, one of the big things that I wanted to call out is this little Python concept known as a decorator. Now, I am going to show you how you could create a decorator, but to be honest with you, chances are you're not going to be creating a whole lot of decorators on your own. The reason that I'm showing you how to create one is just so that way you can see a little bit of behind the scenes of how these work and how these operate. Instead, the most common way that you're going to interact with decorators is by using decorators as part of your code. So if you look through the how to create and you just sort of go, well, all right, but I don't necessarily see a lot of places where I'm going to use that, that's just fine. The big thing really is in using decorators that are part of a framework, such as Flask, that you're going to be creating your application using. So with that, let's talk a little bit about decorators. Now to do that, I actually want to take a small step back here and talk about some programming components or some programming concepts. In particular, I want to talk about objects and then functions or methods. Objects are nouns. They're data constructs. They're the what. They're the things that we're going to operate upon. We also then have our functions and our methods. There are verbs, there are methods, there are actions. These are all the different things that we're going to be able to do. So for example, my OS, you might consider that an object. My getEnv, that's going to be our verb. That's something that we can do. We can go get an environmental variable. Our decorators, then, are sort of like the adjectives. They allow us to describe our code. They allow us to add additional meaning to our code. So that way, if we're running it inside of another environment, maybe we're running it inside of Django or we're running it inside of Flask, that Flask knows what it is that we're trying to tell it or when it should call different things that we've created. Decorators are used most commonly to be able to add additional functionality to your code. Let's take, for example, this little snippet from Flask. Flask is a web programming framework. So what we're going to do with Flask is we're going to create a web application. Now, at the end of the day, when we're creating a web application with Python, what we're really doing is we're allowing people to call methods, to call functions that we've created. And the way that they're going to do that is by specifying some particular URL. So if you're thinking about maybe a public API, or you go to www.somesite.com/products and then maybe some product name, and you're curious, hey, how is this then knowing that it's supposed to load up the details of a particular product? Well, the way that it knows that is because something has been registered that says, hey, when a user navigates to this URL, this is the method or the function that I want you to then call. So what I want to do is I want to register this so that way when somebody navigates to my server/APIs/products, that we're going to then call whatever's inside of that function. And it could then be, code to go call a database or whatever. The code itself is really not the important part. The important part is right up here. The important part, let me clean off all the ink on my slide here, and let's highlight the important part. The important part is right here, that little route registration. What I want you to notice with that route registration is that API/products, hey, wait a minute, that matches this API/products right here. So what I'm doing with this little route decorator is I'm now telling Flask, hey, when somebody goes to API/products, this right here, this is the code that I want you to call. So that is what's going to make the magic happen. That is a decorator. Now, you might decide at some point that you want to create a decorator on your own, or maybe you're just curious, hey, how does this work behind the scenes? And this is what it might look like behind the scenes. So what we've got up top is we've got our decorator. And the name of my decorator is Logger. And you'll notice down below that I'm going to call Logger the exact same way that we had previously. So instead of using route, instead I'm going to call Logger. Now, what we need to do is we need to tell Python, hey, if somebody uses our decorator, we want you to call a particular function. That's this wrapper function right here. And we're going to return this back. So this is my code. I'm going to print out two little messages. And then in the middle, I'm going to go ahead and call your code. So the eventual results here, when this code executes, is we're going to get this output. That we're going to see that logging execution. We're going to see the code that was inside of our function, inside sample function, and then we're going to see done logging. That is how we create a decorator. Now, I do again want to stress here that it's not very often that you're going to find yourself creating a decorator. So if you're looking at this and you're going, hey, I'm not really sure when I would ever do this, that's okay. The most common time that you'd be creating a decorator on your own is if you are going to be creating your own framework. There is some power here. So for example, if I need to log execution, which is sort of what I'm trying to demo here, or maybe there's something where I need to do some level of authentication and I need to make sure that the user is logged on, then I might go ahead and create a decorator. But if you think about it, those are relatively esoteric. And if you also think about it, chances are somebody else has already created a package for you. So if you're looking at this and you're going, hey, you know what, I'm really not sure what's going on there, that's actually just fine, because again, the most common interaction that you're going to have with decorators is when you use one that somebody else has already created, which is what we're seeing right here. Okay, so what I'm going to do from here is I'm actually going to do a real quick demo on how you might create a decorator, how you might then call that decorator that you've created, so that way we can see that little bit of behind the scenes in case you did want to go in and play with it, or you were going to create an application that was going to use them. But again, and I know I've said this before, but I just want to highlight it one last time, the most common place that you're going to interact with decorators is when you're going to use them, like you've seen up here. Let's get in and take a look at a demo. Let's take a look at how we could create our own little decorator. So I've already got the code here just to save a little bit of typing and give me the opportunity really just to kind of highlight the different moving parts. So what we've got here is this is the code that's actually going to be executed when our decorator is run. We're going to print out a little thing on the screen saying logging execution. We're then going to run whatever function our decorator was on top of, and then we're going to print done logging at the very end here. So this is what's actually going to execute. Down below, we're going to set up our little decorator call at logger, and this is going to be our little function. So the end result here is it's going to print out logging execution. It's then going to run our little sample function. So in our case, it's going to print out inside sample function. And then last but not least, it's then going to print out our done logging. So let's go ahead and bring up our little environment. I'm going to say Python and then our little demo file and hit enter. And that's the output that we then get. You'll notice that it prints out logging execution, inside sample function, and then finally done logging. Now, again, I know I said this multiple times. Last time I'll say it, I promise. The most common time that you're going to interact with decorators is when you're going to call them as part of a framework. But if you ever decided that this functionality might work in something that you're building, that is how you could go in and create a simple decorator. So now that we've seen all the different moving parts, what we want to do is close this little video off and kind of wrap up with a few odds and ends afterwards. Okay, well, if you've made it this far and you actually watched all the videos, well, then congratulations there. And hopefully you've left all of this with a decent understanding of Python. But chances are you might have one big question, and that is, where do we go from here? What does an advanced or an intermediate Python look like? And the answer is really, it's sort of up to you. It's now on you to go forth and explore.
Yeah, absolutely. But what we hope we've done is we've built enough of a foundation for you over these series of little lessons that you can now go off and look at things like online tutorials and now actually look at the code and go, you know what? 80% of this actually looks familiar. Don't expect to understand 100% of it. That's the point of a tutorial. It should always be teaching you something new. But I'm really hoping that now this is done, there's some tutorials and things you can play with and start learning on your own in the direction you want to go in.
Exactly. So if we take a real quick look at one tutorial that I have right here, which is building a Flask app using Azure Cognitive Services. Now, Flask is near and dear to my heart because I'm a web developer at heart. And if we start scrolling through this, let me see if I can't get this to start scrolling correctly. What we're going to notice is that it gives us some prerequisites. And one of the prerequisites is, that you've got Python. Hey, congratulations, you've already got that. Visual Studio Code, congratulations, you've already got that. So you can, check those boxes right there. And then it's going to start to walk you through everything else that you might need. Now, I want to scroll on down until we start to get to some of the pieces of code here. And what you're going to notice is that these are things that we've already played around with. So we took a look at decorators, and that's what you're seeing with that little @app.route and the little /. Or if you take a look down below, you'll see another one, and then you'll see that define about, and then a little return of a method call. We've seen all of this already inside of our videos, and that's our hope here, is that we've given you enough information so that way you could go in and start exploring some of these quick starts on your own. Do you have a quick start that you wanted to show?
Yeah, my passion, you're a web guy, that's your happy place, but my happy place is playing with data, machine learning, artificial intelligence. So I like playing with a lot of the different services that allow me to analyze images, extract text, because I think there's so much fun you can have in that space. So I've got a quick start here, and this is actually the one, it's similar to what I did in the exercise when I talked about APIs. But now you could actually go, and I pulled this one off docs.microsoft.com, and if you go take a look at it, what you'll see is it says, hey, Analyze a locally stored image to extract visual features using a REST API. And if you'd read this before you watched the videos, probably has a lot of stuff in here that'd be very confusing. But there's a few things that are different. It talks about using a Jupyter notebook to write your code. Jupyter is just another development environment for writing Python, so you can absolutely do this in Visual Studio Code as well. It says, you need to create an Azure subscription, install Python. We know how to do that. We need that subscription key for computer vision. We saw how to do that when we talked about APIs. And it talks about some Python packages that you need to have installed. We've learned how to install Python packages using pip. We've learned about pip. Suddenly all these weird commands and language in terms they're using are starting to make some sense. But don't be afraid to go rewatch a video if there's something you got stuck on and need to go back. And then you go, it says, hey, copy and following code into a text editor, like Visual Studio Code. Replace the subscription key with your key. And as you go down, follow the instructions, and you look at the code, it should start to look familiar. Import, I'm importing a library. We've got a couple of commands we haven't seen. Assert a subscription key, don't know what it is? That's what the internet is for. We're not going to teach you every single command in Python. Use the tutorials as a way of practicing and learning new commands as well.
Exactly. Now, the last little thing that I want to stress is the best time to get in and start exploring is now, while all of this knowledge is fresh. That knowledge is just like any other muscle. If you don't use it, it will atrophy. That I took 4 years of French in high school, and about all that I remember is Je m'appelle Christopher, ma grand-mère est flambée, et la singe est disparu, which is a very rough way of saying my name is Christopher, the monkeys disappeared, and my grandmother is on fire. That's about all that I remember. Why? Because I didn't use it. So the way that you can start to grow or continue to grow in Python is to get in, start exploring, start using it, and the best time to do that is right now. So with that, we want to thank you and go explore Python.